that'll get YouTube streaming. And then there's our debug. I'm going to copy this. Output started, huh? Copy that. Can I leave a note in here? No, I'll just do a text file. There's what I gotta turn into some kind of an activation of the light. This red light right here. I'll have to figure out what messages. Output active true, OBS WebSocket output started. So I'll have to look for output active true and output active false. Contains spring arm or micro, and that's message.payload. But instead we'll do contains started. OBS WebSocket output started. I mean, I could just do OBS WebSocket output started, starting and started. Get rid of this one. So OBS WebSocket output started. Otherwise, if it gets a status, that means it's stopping, or I should also have contains started or stopped. And then I need to add one to this. Bring it up a notch. And contains stopped. I'm guessing it's stopped. We'll find out at the end of stream. Started and stopped. 1 and 2. And then those I will use to activate the light once I figure out what activates the light. Hey, what's up, Einstein? Let's open up the YouTube stream. Sorry, I got a little distracted. Open this up, mute it, and then pop out the chat. How's it going, everybody? Yeah, we're working on not on this stuff. Hey, Madam U, how's it going? W. Okay, there we go. So I got my debugs finally. So now I know what will activate and deactivate the stream. And I guess I don't need the otherwise 3 in this. I don't need an otherwise. Because it's started and stopped. Because starting and stopping, I could make that do something. Starting, oops, sting. If output contains sting. Starting. I can make it change a different color. Contains. Add. Contains stopping. And I could use these for more advanced control. I mean, I could have it so that I hit start on OBS and it turns on all the lights automatically. What's up, Proteus? Proteus! Let's just deploy that. And I'll check the debug at the end of stream. And then we need to play with what, how I activate this thing, the light, how I send it the right stuff in Tasmota, because I know how to send it Tasmota stuff, like payload message off and on, but that doesn't really help when you've got full hue color control. So, but that'll be cool because it won't instantly turn red. It'll turn like yellow and then red and then yellow and then green and then off. I can have it turn, or I could have it turn yellow and then turn off when stream is not active, or I could have it do a very, very low level of light just to let me know that this is still active. Very cool, very cool. All right, so we can put that aside. We're doing we're doing hashtag AutoCAD ad stuff today. AutoCAD ad. So we're gonna do like the final steps of putting together a PCB, and it's more like, you know, hanging out and letting you guys know what the final steps are. And we'll do a little bit of exploration of what we can do on the limited amount of space that I have on this PCB. I mean, it's a lot of components for 100 by 10 millimeters. That's a lot, and I've managed to put it all in there. I'm not going to take credit. I say we've managed to put a lot in there. I had to do a lot of trace ripping in order to get this to work. Like, for instance, how do you get V plus through this little corridor right here? Well, there's plenty of room for it. It's just that you're cutting off a big ground plane over here, and you've got this little tiny ground that's connecting right there for that pin. Nothing is reaching that except on the lower level, and the lower level goes down here to where it goes over to there, and then it can actually access ground. So you need to do a lot of this like tracing of signals back and forth and making sure that everybody gets ground. Here, I couldn't help but put a via there, and it micro bumps out one of these two. It's ridiculous. It's just ridiculous. So I'll talk more about that when we get started. Hopefully it's interesting. Hopefully it's interesting for everybody. Red light. I can actually turn that off for now. I don't think I have that one on Node Red yet. We can figure that out while we're waiting. Oh, there it is. Yeah. So I can toggle it. But I need to send it other stuff. I need to send it hues and stuff. This isn't enough. Well, if I send it toggle 2. No, doesn't understand it. True, false, on, off, or toggle. So bulb 1 might be the wrong designation. Where's those Tasmota things? Light, maybe. And this one is just bulb 1. Servers broker, bulb 1. Color, temperature, and colors. Oh boy. State, dimmer, temp, colors, I think is right. What's that? A sub old enough that it's starting to look at its 401k? 65 months, mahalo, thank you so much. I really appreciate that very, very much, mahalo, thank you. God damn it. That's an old sub. Yeah, we're listening to another Aesop Rock, but this one features Blockhead. It's from, what was it called? What was this album called again? Garbology. So if I'm sending it HSB, RGB, or channels 1, 2, 3, and 4, that's outputs. Output, I don't really care. So this one's set up as? Oh yeah, it is set up as. But then it said it doesn't recognize anything but true, false, 1, 0, or toggle. Payload and topic. I gotta learn how to do this. I gotta look up something on how to do this because none of this stuff works. None of this stuff is working for me. There's a different way to do it, and I just gotta figure it out. Okay, so I got to remember what we did on Friday, too, when I do the other ones of the lights. Maybe I should keep this stuff open. We should just go to circuit board editing mode. Do I have a working... No, this is all related to the Tasmota lights. I need that. I needed that one. Control-Shift-T. This is the one that I need, because I need to set option. Oh, no, I lost it. Oh, boy. Well, whichever one we did, put it in the notepad. I think it was 137. RGBW. White blend mode. Calibration. RGB and white split. Write that one down. Just putting it in a notepad file for later. I think that's correct. Oh, I see. PWM 1 through 5. Maybe I can inject that into the thing. I'll have to take a look at it. I got to look it up. Figure out what's what. For now, I got my notes. And I can hopefully make a recording, you know, active light off of that. I was going to hold the oh bother sign up to it because this will light up with that light behind it. Oh, well. Put that back over there. How's everybody? How we doing today? I guess a lot of other streamers are going to be active, so we'll have a nice quiet Tuesday stream here. It's usually pretty quiet on Tuesday. I've been doing my due diligence to stay live, in spite of my overarching mood being utter trash. Yeah. What else do we have? That's FTDI stuff. Oh, this is our other working document. By the way, I ordered a bunch of the RP2040 chips. I don't know if I'm going to be strong enough to just order this $2 board and be done with it and build it and make my keyboards work. Because if I can just natively use the RP2040, it's going to be very tempting for me to put an RP like a base RP2040 board into the computer into the keyboard with just its own chip as a little takeover board. I don't know if I'm going to be strong enough. I think if we order the boards that I'm working on right now, I think I'll be okay. And then in the background, what I've been working on in order to get my mind off of a lot of things is to work on the module testing module. I've actually started to put a lot of that schematic down because it's a fairly complicated schematic. In that one, I won't be reducing the teensy down to its original chip. I will be putting the module on because that comes with its own USB, and so I can pull that off and reprogram it and put it back on. But I will be reducing the boards, the little breakout boards. I will be reducing those to just their chips because I mean things went so well with the super duper dense mixer circuit that I think I can pull off the slightly larger but even more dense module tester module. Let me open that up. I can show you guys. Mod test mod. There it is. I have been working hard on this thing, trying to get it together. See, I'm still on the initial phases where I will be putting the components down onto the board and then seeing if I could possibly fit all of the structures. I can fit the chips for the most part. Still not totally confident about that, but I am getting down all of the thing onto this thing. I had to steal the SparkFun jumpers, which are hilariously inefficient at making actual jumpers. 2 resistors is a much better layout for this for some reason. Really annoying. These jumpers, they take up, the symbol takes up way too much space. It's this IC takes up as much space as 4 jumpers. Crazy. It's just crazy. But if I can include them in the design, that means there's a little bit more flexibility. One thing I do have to do is potentially these resistors need to become potentiometers. The potentiometers that I have are huge. So I don't know if it'll be instrumentation pots. But I've got all my structure down, so this is designed so that I have 6 outputs, 1, 2, 3, 4, 5, 6. They output into an amplifier. The amplifier turns it into plus minus 10 volts. That plus minus 10 volts can then be applied to each channel if it's an output. If it's an input, that input comes from the jack and then goes into a clipping monitor, and then a gate monitor, just in case. It has a ESD cap on it, but then that channel will also potentially go into an input. So if that channel comes in, it's not used for any of that other stuff. It can come into one of the 6 inputs of the muxes. The muxes then put it on a right or left channel. So there's only 2 complicated inputs on the thing. The analog level of that channel is then monitored from 0 to 3 volts through the MCP 6002, which can only go up to 3 volts. I'm not sure if I'm going to put a potentiometer on that. Maybe if I don't put one on that, I don't put one on this one either, and I find ideal values, and then we allow this thing to adjust itself. So we've got a plus 10 voltage reference and a minus 10 voltage reference that you can then apply to this. It'll act against the minus 10 voltage reference here, bring it into a plus minus 3 volt through the ratios of resistors on these things. And then if this is at a certain level, we can measure it through the PCM 1808 and through our analog input to make sure that it's receiving the right stuff. This does not take in a DC voltage, but we can measure the DC voltage here, and then we can turn it into an AC wave at that amplitude, and it can be measured through the PCM 1808. And then we can calibrate everything, basically. That's the idea. So that whole bit of circuit, that's a lot of stuff. It's a lot of ICs. There's only 2 little switches left over that I'm thinking about an application for. No idea what those will do. We've got 6 buttons, 6 LEDs, 6 inputs, a TNC 4.1, an encoder, inputs, muxes, amplifiers, outputs. It's a whole slew of things. So on the PCB, I haven't really kind of worked out, that's the wrong PCB, where everything is going. That's what this whole mess is. It's just a whole bunch of parts that have been deposited. Oh my, look at all these jumpers, holy shit. Where am I going to put all this stuff? Holy crap. I got all these capacitors and resistors. These are 0603 rather. A bunch of transistors that have to go in, and a bunch of more resistors. There's air wires everywhere. It is a nightmare. It's a nightmare. I've gone down to this size of op amp, the little guys. Routing, testing, module, module, routing, module, testing, module, routing. Simple. Hey, what's up, Mr. Yan? How's everybody doing? Yeah, so these are luckily QFN op amps. I think I trust them to be instrumentation op amps. The MCP 6004, I might need to find an equivalent for these guys, the 6000. But the 6002 is really all I need. So actually, that's fairly minimalistic. So that may be okay. Max 308s, I already have in my thing of parts, and those are one size. So LM1117, is that going to be enough current to power everyone? The one we had was very hot, which would mean that I would need a big heatsink on it. So I don't know about that one. And those are the major parts. I have moved them over to metric locations, so I made a big note for myself. Top layer on odd grid, spacing is new, 3D files need fix. My front panel and my panel stuff, they're all off by 0.01 of a millimeter. 0.01234 of a millimeter. So I'll need to metricize them. And we'll need to do the thing where when we have a through-hole part, we cut the leads to be short enough to be flat. They need to be absolutely flat. I don't know about cutting the leads on a shrouded connector like this. I may have to solder it and then file the leads down or something. I don't know. Something crazy is going to happen. Because we've got a lot of overlapping parts here, and I really would like this to work on one board. Is it going to be 2-layer? I don't think so. I don't think so. Look at how dense this is. This is all the room I have to fit everything, unless I put up another board. I could do that. I could make it 2 boards. It's just kind of like pulling teeth when you have to do 2 boards. Or rather, I need to make the decision now to do 2 boards, and I don't really feel like doing that. Put it up on some of the low-profile standoffs, and then we got plenty of room for everybody. Because yeah, this stuff will all certainly fit on 1 board. It's just the fact that I've got all these connectors and then this daughter board sitting up on top. This thing has its own voltage regulator, so maybe it could supplement some of the 3 volts. And I've got 5 volts coming in from this connector because I want to use the 5 volts in my little module tester board. We're not using that 5 volts, so I think the voltage regulator is probably going to waste most of the time. What board is this? This is the module testing module. This is supposed to be a vacuum fluorescent display module that I can then use to put signals into other modules and measure the signals coming out of them. Where did the 3D render go? Here it is. What's up, Run Dog Cat? This little guy right here. So this is a reference to the VFD that I have. Bought them a little while ago. They're not as cool as I'd like them to be. The more modern ones are easier to control. Ours has kind of a little bit of an archaic serial control, but they look really good. It's not for testing VFDs. It's for testing modular synthesizer modules. So I've got a little bit of room for your fingies to move this selector wheel back and forth and click it in. This is a lot like a crimes and ornamentation module, except this one very specifically is for testing other modules. I mean, I could probably come up with a crimes and ornamentation module that would be specifically for testing other modules, but that's a 4-channel DAC. We have 6 channels, and then 2 channels can be monitored. So we could output on all 6 if we wanted. We could output on 4, input on 2. We could have a gate on another, et cetera, et cetera, et cetera. And then we've got buttons in here to control the different features. Where on earth did you find VFDs these days? Noritake e-tron sells VFDs, and they sell nice ones. I got them off of eBay. What are the advantages of doing CAD and CAM all in one program? I don't really... Wait, computer-aided... What are you differentiating? What's the difference between those two? Because I'm not totally sure about that, CAD and CAM. CAM is the, the thing that moves the thing making it? CAD and ECAD. Do you mean electronics design and physical design in the same thing? Like the Eagle part of Fusion. Well, okay, so I've always used Eagle, so I know Eagle. Eagle does quite a good job for me and for the hobbyist in allowing me to lay down traces in a logical manner and create a nice little circuit board. There, other programs might boast better automation. I haven't really tried the automation in Fusion. I'm used to like 10 years ago with Eagle, where it would do its best to lay out your traces. I'm sure that Eagle can probably do some pretty amazing things these days. But so I know Eagle. I know how to design stuff in Eagle. And it's just what I use. So it's what I continue to use. And as I got into 3D printing, Fusion 360 came into focus. And since I cut my teeth in college learning AutoCAD, I know how to lay things out in a sketch and extrude them into bodies. And that lends itself to 3D printing very well. That sort of workflow where you lay down a 2-dimensional drawing and then you extrude from there. It's literally how they're building 3D printed structures, right? So, yeah, CAM turning bodies into G-code. From what I hear, and I don't know this for sure, me and my high-pitched nerdy voice, from what I know of the way Fusion does CAM, they're really good at it. I've heard nothing but praise for it. I've never used them to do that before, but I hear they're pretty good. So, in terms of 3-dimensional design, I sort of cut my teeth on AutoCAD. I know how to use it. So when it comes to creating an enclosure for a circuit board, I sort of know the process of putting together all the stuff in order to make your mechanical design, your 3D printed design, and then because Eagle and Fusion have been melded together, they've been combined with one another, you have sort of this very nice looking 3-dimensional capability on top of your ability to lay out a PCB. So you can make a 3-dimensional render of your board that's sort of true life, true, and you can actually like plan your solids around that. Really, people use NX for CAD and then Fusion for CAM. Yeah, I do. I hear that it's quite good, but I just don't use it. Use Mastercam. See, I don't know nothing about it. I've not used it. I don't have a CNC. Maybe when I get a CNC. Why is that off? What the heck? What the heck? Oh boy, I gotta work on this stuff. What about this one up here? One's off too. What the deuce? What's going on here? What's going on with my files? It's been a little while since we visited this one. Oh, I must have clicked and dragged. That's probably why this is here. Yeah, that's why that's there. Okay, I must have clicked on the screen by accident and moved it. Anyway, this is just a testing document for now. We only have so much space where we can actually fit this circuit board in order to get this to fit in a modular synthesizer. Now, while I could overlap the two boards, they're really, really close to each other in height. So I could do a board on standoffs that would then overlap this one. That's also a possibility. But what I'd like to do really is just fit all of my components in here. I have a lot of stuff to go down though. There's a lot of stuff that needs to go in here. But again, I don't use the CAD or the CAM. I use the electronics design. I use the three-dimensional design in order to do 3D printed stuff, and then send the board off to get done from a professional service. And we're trying out JLC PCB in these three projects. If I can get this one done in a timely fashion, at a certain point I'll make a call and just order PCBs from JLC and continue on with this one in the background. Yeah, there's just a lot of stuff that's going to have to go into this board. And I'm going to have to organize all this stuff so that it makes some sense where things are laid out. God, look at all these air wires. Holy crap. I've got a little bit more of this schematic to do. We're not going to do that today. We're going to work on the mixer today. But like, I have no idea if my layout of which amps are where makes sense. It might not make sense in terms of board layout. I've gotten JLC PCBs before. I forget if it's Seed Studio's solder mask layer is a little bit fuzzy. I think JL has a good solder mask layer. I don't know what their absolute maximum capabilities are. I think I did the After Dark service I did with the motor control PCB that didn't work out for some reason, but I'm hoping they have decent quality. Their what is it? Their minimum specifications are pretty good. I've been able to fit a lot of stuff onto the boards with their minimum specs. And we will get into that when we start, but I'm a little bit above minimum specs for what I set for these. That's what we're working on today, is the really skinny dense board. This is the mixer. Julian's absurd volume mixer. We have to figure out what we're doing with all the markings. I don't know if I need to delete these. I think I can keep these for records keeping's sake, but they're not going to be on the board itself. They're just there so that when I build the board, I can identify what parts are what. Because there's no room for actual markings on this board. I really cannot. These are the minimum size, I believe. They're close to the minimum size. And they're just way too big to fit anywhere. Like, there's nothing, that's not going to happen. I can put that there. That's the size of the resistor, though. Could you build an oscillator using comparator ICs? Yes, in fact. You could build a very nice sine wave generator. You can build square wave generators with several oscillators. You can build just regular old, self-perpetuating oscillation circuits. You can have variable oscillator, comparator, comparator versus op amp. Amplifiers you can do it with. Can you do it with comparators? Yeah, absolutely you can. You're just basically making a flipping state machine with it. If it's high, go low. If it's low, go high. I think. It's the whole basis for all of electronics design. oscillating stuff. Most of the components that we've built are essentially geared towards oscillation. If you have a vacuum tube, you have a filament, a heating filament that's emitting electrons. You have a what's it called? A grid or a screen. Basically, the grid is designed to allow or block, essentially through charge, the electrons from passing over to a collector. And so you have your grid, your collector, and you have something at the bottom that's emitting the electrons, a filament. And so you energize the filament and you get a certain amount of current from the collector. If you have a positive charge, a more positive charge on the grid, it goes more, I guess, negative because more electrons run through, or whatever, there's a certain amount of current flow. If you go more positive on it, or more negative on it, it limits it all the way down to a certain negative value where it blocks. And so if you control the oscillations through that, it'll then create larger oscillations on the output. You can have a coil that goes to an antenna with a coil that does a very small amount of electromagnetic oscillation because RF is oscillation. So you get some oscillations through there, you amplify them through the tube, they go into another tube and amplify them even further. You can put it out to a speaker, and then you have a radio. You just have a radio. You have an amplitude modulated radio. So that's been kind of the basis of wibbling waves for as long as we've known electronics to exist. And those principles are baked into all of the stuff that we build. So yeah, of course you can have an oscillator with almost any component. You can have RLC. That's an oscillator. So the basics of oscillation and frequency have plagued dV over dt. So much math that I've forgotten. Change in t. No, wait. Wah! Times e to the negative dV over d. My makerspace uses VSCarve for a CNC router instead of Fusion. Our expert says Fusion plunges too much. Interesting. That's an interesting. Yeah, I don't have enough experience with any of the machines in order to know, Fusion plunges too much. I wonder if I bet you there's a setting for that. But everybody loves the Fusion thing. I've gotten lots of comments about it. Oh, I know Fusion for the CAD CAM. I've never used it for electronics. I'm like, how much in the minority am I here? Keeper of Maps. 60 months. So we had Mahalo for 65, and then 5 months after that, Keeper of Maps began their streak of subs. 60 and 65. Thank you so much. I really appreciate you guys subbing to this channel. Does the math. Don't do the math. Don't do the math. We don't need the math. How's it going? Happy Tuesday. Oh, geez, 5 years. I told you not to do the math. I told you. It's not worth not worth looking at. Thank you. Yeah. So I have not tried the Fusion Cam program, but that's the whole pandemic. Yeah, it really is a whole pandemic, isn't it? Yeah, things were different back then, huh? We can start talking about back in the day. It doesn't feel like it was back in the day. It feels like last year. Just went out and bought some real vanilla. Oh man, I hear that stuff is really good. Shouldn't you put it in like a bunch of vodka and make your own extract? That's what people do, right? They take their vanilla, they throw it in a jar, and then they throw a bunch of vodka in there. You're the only person I've ever heard of who uses Fusion for electronic design. Me and the people at Fusion 360, because if you notice, this is a hashtag AutoCAD ad. I'm one of the few people that they found that do it. I don't think I've used Everclear for making extract. Yeah, whatever pure, I guess vodka counts as a purish alcohol. Everclear is, of course, just grain alcohol, so you're getting straight to the chase. You're cutting straight to the chase for that. Skating on the canal and gravity. Why are you skating? Did you get a cool video out of it at least? Oh man, sorry to hear. I hope you heal up good. I've been doing okay here. The temperature dropped extremely. So I was on the walk with the puppy dog, and I've got my gloves on. And my gloves are, of course, from fucking Amazon. I'm so sick of that site. But it's what I've been justifying, you know, the purchase of their super duper tier, because I use it for streaming. I need to get parts in quickly sometimes, and having that carte blanche shipping ability is great. I really would very much not like to be using it. But anyway, so I got Amazon quality wool mittens that have the little things you peel off, and then you got the fingerless gloves. They're really great for reaching into my pocket, getting dog treats or poop bags, because it is fucking freezing outside. It is in the tens of degrees out there, Fahrenheit, which puts it into the negatives for you Celsius enjoyers, into the almost the tens of negatives. It's sort of in the 1s and 2s and 3s when it is in the teens over here. But yeah, it is cold out there. So I went out and I got my super gloves on, and I noticed that my fingies on my left hand were getting a little bit cold. And it turns out there is like a, what do you call it? Like a spandex almost insert that goes over the fingers that's under the sort of woolen cover, and that's a wind blocker. So when there's wind, it'll cut through stuff like wool. Wool will keep you warm when you know the snow gets in there and it gets wet from reaching down and grabbing a poop bag, but grabbing poop and putting it into a bag. You know, because you get snow all over the mittens. And you know, grabbing the leash after I let Willow run free, she gets snow on the leash, and so I grab it with a mitten, and that keeps my hand warm because it doesn't get wet. So anyway, the spandex or whatever the hell it is on the inside of it sprung a hole. There's just a hole in it now. And I've had these gloves for like a week. They're immediately disintegrating in front of my very eyes. Just absolutely terrible quality. Anything you get off of that site, I guess, nowadays is like that. Just bad quality. I dropped my beaver tail pastry. Only got 3 bites before gravity. I used to go into DC proper from where I was in Falls Church. So I was in Falls Church, DC, and we were right at a metro stop. The house was probably worth multiple millions of dollars nowadays. We didn't own the house, but I guess I could have rented in the pursuit of buying. I probably should have done that, because then I would have had a house in Arlington, Virginia, or sorry, Falls Church, Virginia. That's like 3 blocks from a metro stop. Anyway, to go to my endocrinologist, go to the metro, go into DC proper, and then go into like a pretty swanky little town there right on the outskirts of the Beltway. That was great, and I went there one time, and I walked by a place that sold fancy cupcakes. I said, oh, sweet, I'm going to get some fancy-ass cupcakes, man. I just had an endocrinology appointment. My entire diet over the past 3 months was just closely evaluated. I'm going to cheat. So I went and I got these super swank-ass cupcakes, and I get on the DC Metro, and almost immediately as the doors were closing, somebody busts through the door and bashes into me with all these cupcakes. What the fuck? Like, I managed to catch the thing after doing this with it. And so everything was just completely, yeah, it was such bullshit. It's like, am I going to be like, bud, you owe me like $35 in cupcakes. Like, what the fuck? What do you do? I'm not going to make a scene, but that's really shitty to just run in on it. It's like, dude, the metro runs every like 10 minutes. You can just wait. You don't have to run into a fucking, man. And this is in the middle of the day. Middle of the day. What are you rushing about? Where do you got to go? Where do you got to go? Jeez. A lot of stuff on Amazon you can get on AliExpress for half the price. The only difference is shipping speed. Yeah, and the quality is also equally shitty. At least you're paying for what you get with the low quality stuff. Those gloves have kind of saved my ass, though. I mean, it was really cold out today, so. Sorry, Chad, I didn't mean to trigger a bother. No, it's fine. It's fine. This was 8 years ago, so it doesn't fucking matter. I still ate everything that was in that bag. But yeah, what are we doing? What are we doing? We're trying to round out a couple PCBs. I want to get these PCBs ready to order. I've dived into the module testing module that'll help me further my goals of getting this audio stuff much more easy to work with and being able to finish building a synthesizer, whether it be digital or analog, and do all of the tuning tasks that are required to get this thing up and running. So that's going to require probably LVGL, which is like a menu programming system in for like a bunch of different microcontrollers. LVGL, I don't know, the audio tools in the Teensy, and a little bit of concentration and design. I've been trying to actually get stuff done in spite of ADHD. So I put a lot of work into this stuff, and we'll kind of go over the work that I've done in just a little bit. I mean, we've been chewing the fat for 40 minutes. We'll get started pretty soon here. It'll be a quiet Tuesday stream of doing very eclectic circuit board stuff. Oh, wait, 8 days ago. That's not a current alert. Oh, this stupid shit. Apply for the front page as a Twitch partner. I have to write up a little blurb of what I'd be doing. I'm not going to do that. I mean, maybe I could try doing that and try to get on the front. What do you guys think? Should we get on the front page of Twitch? It's maybe the only chance for channel expansion that I'd ever get. Should I start champing at the bit off of that one? Maybe when I order some PCBs. You apply a month early, though, so... It's been tough to get time to work on the PCBs and stuff. I don't know what the deal is with me actually getting time to work on things. I feel like I'm always walking the dog these days. She gets a lot of walks during the day. Maybe she should get a few less. Because you sit down and you start to work on stuff, and then there's like 5,000 things in your head at once. Any little distraction and it's all just gone. It's a lot like programming, although it's a little bit less once you get your notes down, because we've done the physical work in order to prove out the circuit that we know kind of mostly works the way that we want it to. The only other things that would be brought to the table would be the perils of density and constructing such things, and maybe just some unforeseen pin-out things that I didn't consider. Now, I've been careful about that. I made sure to check over my design, and this all goes into what we will be talking about, but making sure that the pins that I am portraying up here, like the amps going into the amps, are proper. I've gone back to the breadboard design and double-checked some of the things that I put down on paper. I shouldn't be talking about that. It's just all that's on my mind, because it's going to be the subject of today's stream. Walkflation, yeah, something like that. Oh boy, don't get me stressed about that stuff. Been a tumultuous, 24 hours. Waka Flocka Flame. Yes, yes indeed. What did he do? He did just the song where he says his own Waka Flocka. I don't know. It's like, are they still relevant? I don't know if they are. I thought Waka was just what Fozzie says, but now everything's Freddy Fazbear, not Fozzie. Fozbear, Fozzarelli. I can't keep up. Yeah, I want to get these circuit boards ordered. Maybe we should get back to work. Smoke break's over. We'll have stuff to talk about when we're actually streaming, huh? How about we do that? So I'm gonna end the stream now. Well into retirement, sitting in a California mansion. You get like what, 5 years of relevance in the modern music scene, if that. It'd be, you're lucky to fall out of relevancy without some shit going down. What up, Herr Boffin? How you doing? We're gonna get started. Bonk, bonk. Bonk. All right, welcome to the stream where we hide out. We're gonna hide out from everything that's going on everywhere, and we're gonna look at circuit boards. We're gonna concentrate on the projects that we've got under our nose, things that we can control. I've got several designs that I'm trying. There's so much distraction around here, and I know streaming is the incarnate of distraction, but when it's motion detected at the front door and the dog barking, only stream is allowed to distract me right now. I'm going crazy. Anyway, okay, so we've got a couple projects. There are a couple things that I want PCBs to be made for, so I've gotten back into PCB design, and oh look, just in time, I've got hashtag AutoCAD helping me out with my copy of their software. My copy expired. I was going to go down to the free version. They contacted me and they said, hey, if you want to do like a couple streams a month where you hashtag AutoCAD ad on the stream, you can use our software. And I'm like I'm going to use it anyway. So yeah, let's do that. Like, let's just do that. Sign me up. It also, maybe we can collab with some other streamers if they need my help. But they have got a little program, and apparently they don't have a lot of people doing electronics in Fusion 360 AutoCAD. They don't call it 360 anymore. Bother. What's brand alert? Brand alert. It's AutoCAD Fusion is what they call it. So AutoCAD Fusion. Not a lot of people are using it. Mostly, I think it's because of the paid tier structure that they've gone to, and that's just how AutoCAD has decided to make their way in this world. It's not easy being out there and trying to make a profit. I like the program. It has a lot of nice options for collaborative efforts. It allows me to do, Autodesk Fusion, I think. Okay, yeah, sorry. The branding, I got to reread that document. I think it has a lot of very nice visual options. It feels a little bit like the photo. No, that's not right. I don't know how to compare it. It's like very simple on its surface, and if you peel under the layers, it gets more complicated. It's like ogres. So I like the software. I've used it almost exclusively. I tried Rhino. I've tried a couple other programs. I tried FreeCAD. I tried KiCAD. Not seriously on any of those efforts. I used them for about a day or two. And I said, I don't really understand what's going on. I'm sure if I spent more time, I could learn them well. All of these CAD programs are good. They all have their advantages. They all have their disadvantages. I'm not going to put it in the table for you because I don't care. I like using what I use, and I'm very effective at it. It is like pulling teeth at times. All of them are. They're frustrating at times. You lose work at times. That's how they all are. But I know how Eagle lays out a PCB, and Autodesk bought Eagle. And they put it into Fusion, which is lucky for me because that's also the CAD program that I use to make three-dimensional objects. I got into 3D printing, and so now it's all rolled under one lid, and I can just do a napkin to physical thingy project in one piece of software. Kind of nice. I don't know. I guess if they decide to pull the plug on it, I will be one of those people that's very, very annoyed. Now, I've made backups of all of my stuff, so obviously I could migrate things over into another program if I need to, but for the most part, they've been great about, this program. So we're doing a hashtag AutoCAD ad. I am not being overly positive about them. I'm not allowed to be. I have to be just the way I am with it. So if you think I'm being overly positive, that's on me. That's on me. That's not on them. Beside FreeCAD. Wait, so you probably use FreeCAD, so you're incredibly biased towards it. Because I've heard people complain about FreeCAD as well. People always behind closed doors, people always complain about the CAD program they use. Just all right, so anyway, laying out the circuit. So what we did is we took this mixer, which was an idea by my buddy Julian. He's one of the only people who I will accept coming to me with ideas. Because ideas are cheap. Ideas are really cheap. It's the execution of the ideas. People go, oh, I came up with this idea to do something. And you're like, great, keep that to yourself, you fucking asshole. I mean, the whole point is you can come up with any idea. I think garbage should be fuel. Let's put garbage into cars, and that'll be fuel for cars. Let's get some engineers together and make that happen. I'll be over here coming up with more ideas. What, huh? Like, people come to me with ideas all the time. The only person that I really accept for things like that, especially in the music scene, is Julian, because he knows more about modular synthesizers than I do. And so this is one of those ideal candidates where he said, hey, I need a mixer that has certain properties for stereo inputs. And it seems like it's a specialized tool for when he and Dave get together, they want their one output for all their stuff. And they want it to be a nice output. FreeCAD has good use. All the other ones I can respect. Oh, FreeCAD has no good use. Oh, I see. Oh. Well, I tried it for like 10 minutes and I really didn't kind of get it. I didn't get it. Okay, so Julian wanted a specific mixer that has certain properties that he can't find anywhere else. And I am learning over the course of making his thing that there's a reason nobody else has done this. What we need are 4 independent channels. Each pair of independent channels are controllable with one control. When you unplug one of the pair of independent channels, it'll send the other one to stereo, to both channels. This is all well and done. This is very easy to do with the stuff that we have available to us. But it has to fit in 2 Eurorack panels. Eurorack panels, it's like 120 millimeters, 10 millimeters on each side. So you've got 100 millimeters for your circuit board. There's a little bit of wiggle room in there. And each panel is like 10 point something or other. No, it's like 5 point something or other millimeters. So in that 5 point something or other, we have about 10 millimeters to play with for the PCB itself. So 10 millimeters wide, 100 millimeters tall, 4 inputs, 3 controls, 1 output. Now, these things have dimensions. And so we discovered in laying this thing out that we have just enough. Let's do a 3D render of this thing so I have something to talk against. Here's where Fusion 360, in my mind, excels. You have a simple set of tools. You put together your 2D PCB. As long as your parts files are up to date and they've got all of the right 3-dimensional parts in them, and all the pads you like and all the stuff you like, then you can do a quick render of the board with relative ease. With relative ease, you can do a 3D render of your circuit board with click of a button. Actually, it usually doesn't take this long. It's a little bit faster than this typically. And we use that. We use that to our advantage with this project because, you know, only had so much space. So we put together, oh yeah, I disabled all the packages, but we can do a render of the PCB that includes all of the 3-dimensional parts that make it up. And so we figured this is the maximum number of devices that this thing will possibly fit. That one is actually very, very close to the edge, and that makes me a little nervous because these edges of the PCBs are at their absolute maximums. So we have literally no more room in 2 Eurorack panels. So that did it for the mechanicals, and okay, so we have enough room to put the I/O down on this panel. That fits. What about all the circuit elements? And so we stopped and we thought about this for a little bit, and I thought about what is the minimum amount of circuitry that will allow me to put together all of this mixer. It's actually a lot of stuff. It's actually a lot of stuff. And maybe it's because I don't know enough about analog design, but I don't think so because I've been learning quite a bit about analog design. You see, a single channel mixer with multiple inputs is very easy to implement with an op-amp. You put a bunch of resistors into your op-amp circuit, and then you amplify or buffer or whatever the signal, and then that goes out. Or you can do individual buffers on channels and put them all to one single line where you can do the gain up and down. Well, the more stable and featuresome and nice and usable the amplifier is, the more stuff you have. Julian does have a board that is a mixer, but it is literally one op amp on the whole thing, and I'm jealous of that design because it's so easy. But what we have are specific needs. We have 2 stereo channels that need to be dimmable with 1 knob, because supposedly what I'm doing is I'm assuming that the stereo is mixed ahead of time and that we're going to use some very similar circuit properties and signal trace lengths in order to make sure that things are relatively almost exactly the same coming in on the stereo channels. So if your stereo's uneven, that's on you. That's not on me. So we have right, left control 1 and 2 going into the mix. Those get mixed together, but then from there, you have a master output that has its own volume control. And because I don't know a ton about headphone design, I got a bespoke, high-quality headphone amplifier that's going to deal with some of the noise and stuff like that that's going into our circuit. So presumably, this is the minimum amount of electronics that I could possibly put towards creating a stereo mixer. And so we took all of those electronics once we figured out an actual, that's the wrong one. Once we figured out an actual circuit for the whole thing. That's not that, that's not that, that's this one. So here is the circuit. We put together everything on the breadboard. I determined that if I were doing this properly, I would need the smallest possible op amp. So I found a component that could sub in. I bought a bunch of them. They were not cheap, by the way. A modern op amp, for some reason, is a little bit more expensive than the TL074, especially if it's in a tiny little package. I get good volume discounts on this, I guess. But so I put all this stuff together on the board, you know, whacked it all together, put it all down. We did some initial testing, and then we jumped immediately to the PCB design because not really time is money, because I guess my time is probably worth a lot more than... Well, anyway, the point is we can buy PCBs for $5. We get 5 for $5. The sooner I can get a PCB design, the sooner we can put this all together in a little thing. I can hook this up to my little test rack, and we can put it through some more poignant tests. So we can do frequency sweeps and things like that. And then we don't have to deal with the rat's nest of wires. You see, I put this together and I tested it to be working, but if you poke it just right, it stops working again because it's been assembled on possibly one of the worst platforms you can possibly have. You know, I think Ciano Cat posted, no, somebody else. Who was it? Was it Adult Grogu? Somebody else posted in the Discord this wonderful design that this fellow put together where he used all of his own wires and he bent them just right to jump over one another. It looked like a PCB on a breadboard, which is all well and good and nice if you've got all the time in the world to bend all of those leads. I kind of do and don't. I did a little bit of both on this. I like to keep it to these things that are low profile to the board, but if you start stacking these up and you don't really account for the lifting of them and stuff like that, and you're only using the lengths that are provided to you by like a kit, you have to do weird stuff with the runs, and then they sometimes tend to like pop out. So you've got to be really careful about that. I did each individual small section I did with the flat lines, and then I jumped to other sections using the rat's nest jumpers. So the thing about that is, like, we could run this through all the hardcore tests, but our signal path is like blah, 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 blah. It like goes all over the place, and that doesn't really represent how the circuit's going to be in the real world. So I wanted to put it all down onto a PCB and then run into all of the problems that we're going to run into, and there's no room for capacitors. I still don't know what really goes into like a good design. Like, you could just quote me on that. I don't know what really goes into like these designs that you get off of the internet. Like you get like a real Arduino board, or you get like a breakout board for something, and it's full of capacitors. Hey, Lawn Dog, how's it going? It's full of capacitors, and all the capacitors have their specific jobs because you know they do, because some of them are missing. Like they decided, like, we don't need this one, but we definitely need this capacitor in here. And you're like, why does that? Why is it like that? Why did they design the circuit like that? I think those engineers are using math. I think they use math to their advantage. You know, they're smart people, very smart people. They're smarter than us. I think what we're going to do, though, is we're just going to put this thing together and order it and figure out what went wrong. Because That's all we can do. We can worry about every little detail, but at a certain point, we have to let go. We have to just let go, order the board. It's not that expensive. We get it in the mail and we go, wow, how did I miss that? That's sort of where we're going with this. The problem is the prototype itself is probably going to be like $60 worth of electronics, putting it together, especially at low volume ordering. All the op amps, like each one is like nigh on $10. I think they're like 6 or 7 when you order them in bulk, but I need 3, and then that's $30 already. We need the specialty part, the what do you call it? The transconductance amplifier, the conductive, the V2164 equivalent. Those are expensive. I have a bunch of them, but we need 2 of them for this design because we need 4 independent inputs, and then we need a volume control after that. And so the volume control I'm putting up to the voltage controlled amplifier instead of something like a gain circuit, because we're using this headphone amplifier. This one is like more than $10 a circuit. So we're using some high quality shit here, folks. These are some nice things. And of course, I'm going to have to make sure that this thing can only get up to an amplitude of 1.7 volts. Up to an amplitude of only 1.7 volts. Because that's line voltage. Planned obsolescence, remove components so it'll fail. What, you mean like capacitors? Talk about manipulation. Who wants to buy a Bamboo printer? Everybody get the Bamboo printers. We're gonna give all of these influencers Bamboo printers, big or large. You want a Bamboo printer? You get a Bamboo Labs printer. How about you? You want one? You want one there? Oh bother, you don't get one. Oh, why not? Everybody has our printers now? All right. No more third-party anything. Go Bamboo. Way to regulatory capture a consumer industry, you freaking assholes. What an asshole move. Everybody should have seen it coming, though. By the way, you can just buy a controller board for any printer. You could replace the one in the Bamboo Labs printer with a better one and more features, and then learn how to use Clipper, and then you can expand your printer and have cooler stuff. I'm sure, actually, by now, it's already been pwned, right? They've already pwned the Bamboo Labs printer. So they've already got open source stuff. What is Bamboo Labs going to be giving you with their printer? They build the printer. What are they going to do? You're going to download a new feature for your printer? Come on, get real. Stay on the free stuff for printers. And if you get that Bamboo Labs printer, if they ever decide to send me a printer and I'm suddenly super positive about Bamboo Labs printers, wow, they're so great, I've been bought. You can know I've been bought at that point. Because the first thing I will do is replace its brain. So happy I chose Prusa over Bambi. I mean, look, the Bamboo Labs printers looks like a nice little piece of hardware. I mean, you've got this nice little enclosure. You've got 4 spools on the top. The thing knows how to run itself, right? So if other people can figure that out, and they will, then you can just replace it with whatever software you want and use it the way I do. Have a print monitor thing on the printer, you know, whatever the remote printer stuff is that I use. Just use that, like, you know. And then what I do is in Fusion 360, I say export the solid to an STL. I take it to a slicer of my choosing, and then the slicer is connected to my print monitor stuff, and I just go, just send it over there, and it'll do its job. Just in the same way that if you use the Bamboo programs, you can do the same thing. If you want to use other programs, we're learning how. So, I don't know. I think it's a pretty weird move on their part. I don't think they should be doing that. But they made their choices. So if you have one, you can improve it. If you're looking to buy one, maybe you should look at somebody else. All the default profiles are good, but I like how Prusa hasn't fucked me yet. Yeah, that's the, you know what, that's kind of an important evaluation. What's up, Baloo? How you doing? Yeah, if you guys didn't know, the Bamboo Labs has gotten in trouble for closing their environment. They had kind of an opener environment, from what I understand, where you could use other third-party programs in the process of creating stuff. I mean, you can still take your STL. I don't know to what end. But apparently they've closed it off in a way. And I don't know the odds and ends about it, but it's not a very good move considering that the 3D printer sector is relatively open, and there's a lot of different ways to go about what you want to do with your 3D printer. They're trying to make it more like the SLI, whatever the Goop printer is, where there's like 2 programs that you can use to do the slicing for a Goop printer. They both work well, but they're 2 programs, and they're both like totally shilling you to try to get you to buy their software. I've heard people talk about how Prusa looks less professional because you can see cords. Seeing cords makes it easier to fix. That's a weird evaluation. That's a weird impression that people get. Yeah, it's the same thing with like medical devices, where people do not want to see wires. If you're building a device that you're interfacing with a human with, you have to do trials with people with it, right? And so if it's still in a fledgling prototyping state and it's a metal box with a bunch of wires sticking out of it, people really don't like that. They really strongly dislike that. And I dealt with that in the medical device design job. Nobody fucking listens to me, but they were evaluating this piece of gear that you wear while looking at something, reading something, shopping, things like that. Like you look at your thing and you try to mess with it, and then the people behind the glass can evaluate what you're looking at, because it's got cameras that face the eyes. It has infrared facing forward. It looks forward and backwards, and so it can overlay what you're looking at in terms of like if you've got somebody shopping for something, it's a shelf, they're looking at a shelf, you can see where their eyes wander. You can see how they look at an instructional manual and what they concentrate on first. That's a really important thing, because you can make these instruction manuals as optimized as possible, right? That's a family of products. The company that I started with was using one of these products. They had their 2 guys out there evaluating it. I don't know where the fuck they found these people, but this thing was a metal box, and it had this, what is the Nintendo, like the NES blaster. Yeah, the laser scope. It looked like a fucking laser scope, but it was like metal. It looked like a metal laser scope. And this poor lady was wearing this, and it clearly was very heavy on her. But I literally like immediately searched for a competing product and found it was just looked like a pair of heavy plastic glasses that you put on that had all those cameras in it, and had a thing that you put on your belt that has an SD card in it. It broadcasts over Wi-Fi. You can drop in and see the person shopping, where they are in the building. You can look at where they're looking in the thing. See, they have mock-up supermarkets where people do this stuff, and they figure out where exactly to place all the products and stuff. And so this was designed sort of for that sector. It would have also helped with us with reading medical literature, because you could see where they're looking on the screen. You could get a recording of that. You could drop in on it live, etc., etc., etc. I found just like a phenomenally better product. It didn't show as many wires. People don't like seeing all the wires and stuff of a prototype, especially if you're hooking them up to it. So having a 3D printer with a bunch of wires that are hidden, I guess, makes it seem a little bit more professional, although to be fair, like, it's a 3D printer. Like, I don't know what people really expect from the design. All right, so anyway, back to the mixer. Let's I'm gonna wrap up all this distracting stuff. Yeah, being an engineer, don't mind seeing wires. You wrap them in spiral wrap, and then people will ignore them. If you wrap them in white spiral wrap, people will accept them more. For some reason, people, white device is clean. Seeing wires equals encasing is broken. I don't know, man. But anyway, Bamboo Labs, yeah, getting in trouble for closing off an open environment. And so, rightfully so, people are looking to the other companies like Prusa, who believes in the concept of 3D printing, instead of trying to get their own kind of regulatory capture of 3D printing. Boy, am I sick of that. Algorithm control. All right, anyway, Prusa's black spiral wrap around the wires. There's some visible wires routed at the bottom and nicely cable tied. And you can print drag chains in order to hide them if you want, but that's up to you. It doesn't, whatever. All right, anyway, you guys are too distracting. I'm going to minimize the window here. You guys no longer have contact with your streamer. So Julian had a bunch of requirements for me, and one of the first and foremost ones is that this thing was as small as possible. 2 HP was the goal. I unfortunately had an obscene amount of technology that needed to go into this thing. All of these components have footprints, and these footprints can vary depending on the level of technology of the device. So in the case of the older voltage-controlled amplifiers, this only came in an SOIC size. So SOIC being a surface mount integrated circuit, it was sort of the first foyer into what surface mount technology has become today, and that would be a spread out chip. It's a little bit smaller than 1.27, 0.1 inch spaced breadboard. It's a little bit smaller than that. It's not totally tiny. It was sort of the initial jump in the 1980s and early 90s of getting things onto the surface of PCBs and getting them small. This does not come in a smaller package because this is a chip from the late 80s, early 90s. There are redos of this, but because they are more amateur efforts, it's not like Texas Instruments does not make this. This is a low volume PC or low volume chip manufacturing. They just don't get into the quad flat no leads and stuff like that that we need in order to reduce the size. So we have a strict requirement of having 2 of these giant chips on the back of a very small PCB. Well, what it came down to was we can fit all of the components. Can we fit all of the chips? We can fit all the ins and outs. Can we fit all the chips? And as it turns out, we can. The SOIC chips, these giant things here, those have to go under a potentiometer because it won't fit between the Donkey Kong connectors. So I have my quad flat no lead. That's this this thing here. Quad flat no lead chips that take up just enough space for me to barely wiggle resistors in. And the more I worked on this, the more depressed I became, because the more I worked on it, the more I realized that this would work. One of the biggest problems I have is that I was able to do this in a 2-layer PCB. Of all things, I was able to barely fit the entirety of this design, this very, very complicated mixer design, into a 2-layer PCB. Now I have to do some certain things to make things fit properly. Like I have to bend these leads in a weird way in order to get them to go down onto the board. But it fits. It fits, and there's absolutely no way that I can actually do the board edge cutouts on this thing. I haven't done a multi-board design yet, but doing multiple boards would also free up quite a bit of resource for this. I could use those low-profile headers and stuff like that. But yeah, doing the size guide, having relevant 3D models that represent the size of the devices, and getting them into the CAD program, and then getting the PCB sizing into CAD has helped us greatly. The only difference between the connectors, the potentiometers that we're using, and the model that I have is that the model has a center, like, pylon to it. Ours have these, but they're a little bit taller. So with that in mind, I mean, this is ridiculously close. I think it'll work, but this is potentially an area where this thing will fail, is if these resistors don't fit with those pylons. I'll have to cut the pylons for the prototype, if that's the case. If it fits, I will be ecstatic, because those resistors are the ones that adjust the range of the potentiometers. So, I mean, this is a grueling effort. What I did is I put in different functional areas, right? Like I had an op amp that was required for the volume control and got those areas together. Got the components together in little groups, fit the groups together in a minimalistic way, reduced the air wires, the white wires that connect pads to pads and tell you what should be routed. Reduce the air wires so that they don't cross over each other as much as you think they do, like as little as you can get them to, and then arrange all this stuff onto the board so that everything lays out in a logical manner. Like, for instance, this chip has to be flipped. Its pin 1 is down here, unlike the other ones which have the pin 1 up here. Why is it flipped? Well, that's because our input is on one side and our output is on the other. So on this side of the PCB, if this pin is going to face that way, that means that we can have our ins coming in over here and our outs going out over here, where they go to the output connector here and here. So that way, things lay out just a little bit more reasonably. Oh yeah, that does it on the other side of the board. So all of that considered, there were a couple different passes that I had to do on this. I started down here with the output and sort of laid it out one way, deleted it, laid it out in another, tried to get the powers to cross properly, tried to get all the stuff together. I deleted the air wires for plus minus 12 and ground. All the power I hid the air wire for. What that did is that freed me up to make sure that all my signal paths would be okay, because power can go on a slightly more circuitous route. We've got a lot of power going into this thing. Plus minus 12 volts is a lot of leeway for this thing to have. So we let that sort of be sort of a dog-eared point for a later point in time, right? Once I put all that together, I ran plus and minus 12 and left ground to the lurch. Ground, of course, comes in on a ground plane. So for the most part, ground will be dealt with on your typical PCB. Problem is, we don't have a lot of room on this thing. We don't have a lot of room on this thing, and so our grounds were rather broken up in the end. One of the last pieces of evaluation that I had to do on this board was to go over the ground individually and make sure that it actually makes a connection as it goes. There are some pins that are supposed to be grounded that I had to run a manual ground on. I had to run an actual trace in order to get it to connect. Little pieces of ground here and there that I had to sort of connect with vias. And this is something that you have to do in the larger boards, but for this one, it was absolutely vital that I got in some of these vias, because otherwise grounds would not be supplied to different areas. I am not allowed to, for instance, ground this little guy right here. I could really use a ground on that. It's sort of an antenna. It's sitting off of this over here, and it sort of just blaze out in this direction. I have to kind of just accept it. This is an absolutely vital ground, because otherwise we go down here, all the way down and around, and we have the only ground connection that this chip is going to get from the outside world. So this chip doesn't have ground going into pins. It has V positive and V negative. It doesn't really reference ground because it's the headphone amplifier. Its ground is mostly coming in through this heatsink pad on the back, which is really kind of a weird thing for it to do. I mean, it does have pins that go to a resistor and then ground, but so the thing is, on the Donkey Kong connectors on the top of the board, I have to have a circle of keep out, a 3 millimeter in diameter circle. This is a little bit smaller than 3 millimeters in diameter, but I have to keep the solder mask out of there, and I have to keep traces out of there. Otherwise, it interferes with the headphone plug that plugs in. Why do they build it like this? I don't know. They could have bumped it out by like a 0.2 of a millimeter and not had to deal with this. They recommend that you put a 3 millimeter hole through the board. There's no way that's going to happen on this board, because if each of these Donkey Kong had a 3 millimeter hole behind it, that's going to cut off most of my circuit elements. So instead, I made a compromise and I put a keep out area on top of the board. This is like a 2.7 or 8 millimeter diameter circle. I can't put any traces there, which means this chip that gets very hot, by the way, only can have the top piece of its ground pin heat sunk to the layer above. Now these on the fringes here, those will help. Those will help a little bit. And then on the other side, I've only got so much solder mask, and because of the way that all the V pluses and V minuses are run, I guess maybe I could have run V plus to here. If I bump this out, and this goes under, oh God. It would have, oh, that's, okay. Anyway, that's like impossible. But if I did it, maybe I could open up a little bit more of this area to ground. Oh no, but then there's still no. See, okay, so on the blue layer, this ground doesn't connect to anybody. I'm not sure if there should be a thermal pad on that. I guess not. But it doesn't connect anywhere. It doesn't get out of here. So I need a via to grab my ground and bring it out to another ground. So this one on top, this layer on top here, this ground on top is cut off by this minus wire that comes down here and over to this space right here. And so that cuts it off from having a large ground plane. It only gets this. This is the entirety of the ground connection. This will be enough to run the current to run the amount of current that this thing's going to use up, but the heatsink pad is also largely cut off. I guess if I went up and over or something, I could probably get a little bit more in there, but it's tough. So that was one of the first evaluations, so sort of the final steps of this thing is, how is this thing going to get ground? Oh, it looks like, wait, I've got a ground coming in here because of this one that's underneath that. That may cause problems when I do the final, like the design rule checks. We're going to have to ignore all the warnings that it has over this one. Yeah, so I was able to get a little bit more ground. But again, this was like cut off here. It didn't get any of the pads on that, all the thermal pads that could have existed. Just a mess. Yeah, of course I considered a 4-layer board, but the challenge was to get it in 2. And I did. This is ready to go. Except for a couple things. So that's why this stream is learning to let go. Oh, I see. This is only the top solder mask, right? I was like, wait, where'd the pad go for that? This is one of the more annoying ones. Making that look right. I can't go this way. I have to go all the way around. It has to go all the way around for some reason. Ridiculous. Ridiculous. So that's one of the things you have to do is you have to go through and you have to check to make sure if you're doing a ground plane and you're relying on that ground plane in order to bring all of your electronics their right voltages and their supplies and their heat sinks, you have to check that over. So this one is a V negative that comes in here and goes to this big plane because these op amps use V negative as a heat sink. That's why I snuck in. Sorry about the flashing. It's just going to happen. That's why I snuck in these two. Even still, though, they defile a design rule. And so I don't think they will cause any problems. But if they are exposed, actually, they might cause problems. If those are on the top layer, they have a solder mask layer over top of them. Those could potentially short out by connecting to this exposed area here. But I'm keeping a distance between those. Oh, but this is exposed. Hold on a minute. Yeah, if I could move that out a little bit, that would be ideal. Well, actually, I can move it using alternative spacing. So if I hold down Alt, but it's not going to let me get all the way in there with this. And then it violates up here. How can I make it let me do this with the design rule in there? Oh, if I unview the top layer, I think it'll ignore. Let's get rid of top solder mask. Now this, oh, top keep out. If I ignore the top stuff, is it going to let me? Now it's going to bump it out again. Ah, what the heck? How come it let me do this before then? I probably put in the rules later on, and then I was like, wait a minute. How are you getting away with this? Move objects, use Alt arrow key for the alternative grid. Left click to place group. No, that doesn't work. Doesn't help me out. Yeah, it's funny. It let me put those down, and now it won't allow me to jiggle them into place. I would still have that problem on a 4-layer board too. I mean, I'm just going to have to let these violate design rules. Otherwise, the V negative line doesn't really get any connection here. And there's still air wires inside of it, even though it's connected. I could run traces, you know, inside of this thing in order to connect those, but it's largely not necessary. But then on the top layer, I wonder if I can delete the solder mask, and then that would put those under everything, and they would be a little bit safer. Unfortunately with VIAs, I can't delete the solder mask layer, And if I go to the properties and I tell it, where is that? Solder mask off, it still puts a solder mask over it. If I view the bottom solder mask, it's still there. It shouldn't be there. I told it not to. That's why I'm wondering about this. I'm wondering about this. This is not very good. Off. Still there. Weird. So yeah, and the design may look overwhelming. If you just view the one layer at a time, it helps a lot. It helps sort of underwhelm you, and you know, keep you grounded with your design. You can look and you can say, oh, there's not a lot going on over here. Okay, I get it now. I see what's going on. I'm not doing C's and R's on the bottom layer or the top layer. I am doing the component outlines just to give you a little bit of a reference of what you're looking at, but I'm not going to give it C and R designations because a lot of this stuff is way too dense for that. I, of course, have stripe markings on this thing. The stripe being in modular synthesizers, stripe indicates where the -12 wire goes. That's really important, and so are these two diodes that I have. I've got two little Schottky diodes sitting on my power pins. They are at the absolute minimum spacing that I can get them on. They take up almost no room at all whatsoever, but they will protect this thing when it gets plugged in backwards. Hey, what's up, Pyro? How you doing? We're going over sort of the final stages, the final checks of what you should be looking for in your PCB design. Now, one of the things that I can't be a stickler for that I'm usually very careful about is making sure that you've got your grounds cinched up to all of your grounds. You've got all of these little vias sitting here on your grounds connecting the top to the bottom layer. We just don't have space to have them all be perfectly connected. I'm frazzled, so we are losing ourselves in PCB design. Here's one of the areas where ground wasn't properly really run. It was unable to get a lot of the traces, their thermal connections, their thermal pads to ground. So I had to draw an extra trace in here in order to make sure that there was just continuity going to the ground plane. So I added a bunch of traces to the grounds in the area. So you got to look for that stuff. You got to look for orphaned grounds, grounds that are on ground planes that don't necessarily connect ultimately to your power supply grounds, which are these right here, these three. It's kind of frustrating that this doesn't connect either. I put the JLC PCB like standoff distances in there. It just wasn't enough that on a through-hole device, I didn't get these connecting across. That could be a problem on like a noisy board or like an RF board, but when you start measuring font sizes in micrometer instead of points, JLC has like a guide to the font size, but yeah, a lot of it's not really going to be. I don't know. I think this is the minimum size. It's very small. Here, let me get chat back up. So, yeah, I'm just looking for conflicts of solder masks. I'm looking for, we'll do a design rule check that'll get us to all the right stuff, but later you will upgrade it if you need to. Upgrade what? What am I upgrade? I round it. It's funny that the CAD program has all this stuff for making these beautifully rounded pads, right? I rounded out all of my pads. And then you come over here to the solder mask and it's like, why is that like that? It's because they lay out the edge of the solder of the whatever it is, the ground plane, using a sort of a pseudo trace. So it doesn't have this like nice rounded cutout. And that probably won't be all that visible in the final design. It just would have been nice. Oh, I didn't round these pads. Oh well. We can leave these as being straight pads like this, but I tried to kind of round everything out so it looks more advanced. What are they called? Chamfers or fillets are the look of the future. But I think this will be okay. I think this will be good to order, just so long as, and you know, I'm still looking here. I'm looking with you guys in tow. This is one of the connections that I had to make in order to make sure the ground got here. And then, of course, ground is also getting to here. So I had to add an extra little trace. and this weird ass thing is left over. I'm going to keep it in. You know, we can refine it out of the design later if I really need to, but boy, oh boy, if I went to a 4-layer PCB. Guess this one's okay. And what I can do is I can then hit F to flip the board, and I can go to the top layer. So there's presets that you can use. I go to layer stack over here. Preset top. Oh, I need to like, yeah. This is what the top layer looks like. I don't know how to disable all of these little cross marks for all the components that are used. Of course, I can also get a really good impression of the top layer if I look at the 3D one. I can go over here, and I can unview the components, and we get a better impression of what the overall circuit board is going to look like in 3 dimensions, although it's kind of distracting. There's the top of the PCB with a heatsink for the chip below it. I got all these lines that are connecting everything to everything else. A little confusing without all the labels. At least I can see where the silk screen is going to fail. Yeah, it's much easier for me to look at it if it's not like this. If I've got all the signals named and stuff. Which one is this? This one's way back here. So just do a quick pass for anything that's overlapping. Okay, that's a silk screen in between the two, but that's not overlapping. It's just that the silk screen's there. Well, that looked like a smoking gun. Let's see. No overlapping. Nice thick traces on my power. No areas that really could use, you know, like as much as I could use a ground plane in here, I'd rather have these 3 connections, so I'm not going to move this up. I'm going to keep this down towards the via. And if I could sneak it any lower, I probably should. What's going on beneath this thing? I guess I could, although, no, that's not really worth it. Yeah, it's like I could move this down and then I could put a via over here and I would have a little bit more coverage of ground, but I don't think that's really going to make that much of a difference. I don't think that's going to be such a big deal. Although I could move this up, but then the further away I get from the center of the potentiometer, the more of a chance there is that this interferes with something. And I need this via here. So if I move this, if I sneak this thing up and I move this ground pin, I move this out of the ground here, which gives me less design rule flubs, I think I'll be okay. The fun I had with my Z80 board, I was keeping the tracks as short as possible with the least number of vias. The good thing is we don't have to worry about the number of vias on this thing. At least so far as I know. I don't think JLC limits us in the number. There used to be parameters for that. You'd get this many vias for free, and you'd have to count all your vias afterwards. That's why Eagle has some user language programs for counting vias and stuff. What is this? Oh, that's the keep out area of these two, and they're conflicting with one another. But I'm ignoring that because it's dumb. I should delete that on the component. One of these, this one's a resistor, and the other two are capacitors. So those are the decoupling capacitors, and then this one is a mode resistor because you can change the amplifier from being mode A to AB to hybrid. I think leaving it open is what we've done, and so I'm tempted to just continue to leave it open. But if I really want to, I can put a resistor in there. So I left it up to my final call. This, I really wish there was actually copper in here. You know, there's all of this nice smooth copper, and yet you have these clunky keep outs. I really wish that was a little smoother. It should have a little bit more character to it. This one is unfortunately me over a barrel. I have no choice here. I need to get V negative into this center thing to bleed off heat, and there's no V negative plane around this component because there's no room for it to exist. It just won't happen. So I run a giant trace into V negative. I think that the chip will be okay, but just in case I'm running a V negative plane on the upper level, that's going to give me a little bit of stuff to run or to cool off this stuff. Why did I put this one here? What are you? What signal are you? You're a V negative via, but you've got nothing going on beneath. Oh, because you were probably pushed out. I see. So that's not necessary. I'm deleting that one. Oh, and look, we get more ground as a result. Yeah, you're just that much more ground. That one must have been pushed away when I finally did the keep out area on this component. But this one is a giant rules violation, and we'll have to see whether or not it ends up shorting out an audio plug when I plug this thing in. That's gonna be, oh boy, that's kind of a stick. That's not gonna be fun. It looks like I could push it up a little bit. This could potentially push up just a little bit. These have a little bit of growing room on them. This could move up to here. And then this whole thing could push upwards. This would have to come with it. Actually, that might actually work just fine. All right. Gird your loins. Gird them up. Gird your loins. We're going to move this thing up. We're going to move this chip upwards. So here's what happens when we do a major board revision. This isn't a major board revision, but a lot of stuff's going to move with it. So I'm going to go to the properties of this one, and I'm going to unshow the fill. Same with this one. Unshow the fill. Then we want to go to our V negative ground plane here, the V negative cooling plane, and we're going to unshow that fill. So now they're all just going to be represented with dotted lines that we have to think about later on. Okay, so our fills are now just little dotted lines sitting around this whole thing. V negative is locked down right now. Right click, go to lock, unlock. Now the thing about doing that is I'm still in the locking tool. I still have the locking tool selected right now. So the locking tool, the next thing I click on, it's going to unlock whatever I click on next. So I'm going to hit escape, and that'll get me out of that tool. I got to be careful about that. Now, for right now, what I need to do is unview the top layer. We're going to start with this trace. This is our most movable trace. So delete this, delete this, delete this, delete this, get it off of the internet. And I'm working with both layers visible. I'm just making sure that I'm not clicking anything that I shouldn't because we're moving up this one. This one comes up as far as I can get it, which is, yeah, right there, which is a nice spot for it. That actually looks pretty good there. It looks like it naturally should belong. We're going to move this one up with it. And this one's going to get a little stretchy, so let's just kind of work with it. Come on up with me, buddy. You're coming this way. That's right. That's right. That's the ticket. Oh, went too far. Went too far and it jumped. So go right to there. That's not affecting its neighbor. We've got a nice smooth lead into it. Get rid of these excess. We'll put them back later. Actually, we just need to get rid of the one. So leave that one in. That one's got to go because we're thinking about moving everything up. Everything is going to scooch up just a little bit. So this V minus connecting there is not going to be necessary at the moment. We will get to that. So I'm going to move it out of the way just a little bit. These do not have a lot of movement in them. They are a problem. So let's get rid of this. Get rid of this. Get rid of this. This one I'm going to move. Can't move it forward. This one has to go this way. And actually, I'm going to get rid of, well, yeah, that cinches that one. Get rid of you. Get rid of you. Damn these accursed hole rules. Why is it like this? It was like it fits here, but it doesn't go to the right just a little bit. Why? I'm deleting that because there's some baggage associated with it. So we're going to go back to laying down this trace. This one is going to be one of these bend-a-majigs, and it's going to be 0.2. 0.2 is a little bit larger than the 3 mil. I should change the corner radius, but we've got an inch corner radius on this thing. If I center click, where is it going to let me put down an actual? That is restricted as hell. Okay, so V plus, you're going to move back just a little bit. Actually, that one's coming up with us, but yeah, that moves back just a little bit. And that one's actually good to move, so let's just move that there. Although, we could probably come into it vertically as well. All right, we got more stuff here to move. It's when you move one trace, you got to move a ton of different stuff, so. Whoa, okay, you go away. You go away. This is a volt, it's a power trace. So this one's 0.3, which isn't in the CAD software still. It's got its like stock sizes that I don't really like. 0.3 is coming up this way, and we'll just move it to the side just a little bit. Take it to the next layer. That's as close as it goes. And let's just pull that in. Actually, let's redo that. This is what it takes to sort of optimize a design like this. It goes there, and then we'll figure out getting it to this one later. That's just a decoupling capacitor. This one I'm actually going to flip around because our V negative is moving up. So if our V negative is moving up, I'm getting rid of that, getting rid of the internal trace, grabbing the component, and then right-clicking to spin it. That puts that like that. And then I can scooch this whole thing up. These are sort of locked into place. I mean, I could move them, but they're in a decent place. So if I just move it up, what's going to happen right now is it's just going to stretchy the lines out. So in doing that, what I will do... Well, our mix, we can actually... Yeah, we can make that a little higher up. Let's reroute that one. Ooh, this is going to be tough to figure out. Okay, so let's see what we can do here. Oh, this one's still internal. Oh my God, it really is rejecting that. Yeah, I'll just sever these just to... We'll get back to y'all. I think that's as far as we can push it. So let's try to get our mix over there with a 0.2. Yeah. Ooh, that is pushing it. That really is pushing it. But I guess I'll accept that. Now I want to run from this thing over because this isn't on the grid. You can see there. So if I do that, there we go. There's the RMix connection. And then we can do this one. Well, that one can go kind of directly, although it's a little clunky to come all the way out here. RMix needs to drop down and go in there. If this one comes up into there, I mean, that's kind of what it already had. Thinking about that. Hold on a sec. That like that. That's sort of what was already there, and it's not the ideal solution. I guess that works, kind of. This will have to come up with something for. Let's go to 0.2 on the easy one. Go like that. It's going to mean the ground plane is kind of abysmal in this area. Oh yeah, we're still same comment. No new comments. Okay, so let's get this one over to here. And then this, I don't know about doing like an elegant thing with. Try to do one of these. Yeah, that's all right. I guess that looks okay. All right, so that being said, now we need to do the rest of these and somehow get this up into place. Looks like I'll be able to put 2 in there too. That gets it a little bit close up here, but I guess we can handle that. So these are 0.3. Oops, wrong layer. I'll just go like that because that's gonna meld in with the heatsink. Yeah, this is sort of the final steps of like checking things over. It looks like RN2 is going to keep me from. It's going to look so bad if I move these up to accommodate. These don't like to move up. They really don't like to move up. And actually, I should probably run these again. Including V negative. All right. We're okay. 1, 2, 3, 1, 2. It's going to move from one side of the chip to the other, and then we'll put the ground planes back in. Because we need to move this slightly differently because of the vias changing their locations. They sort of synced in, they moved it, cinched in just a little bit. Move this in. That's about as far as I'm going to get with that one. A lot of mess to clean up. Hold on. Wow, that takes a straight shot across the entire board. Maybe I won't move that. Because it doesn't really mean I can get this any closer. That's as close as I can get that. But then these need to dodge that. It feels like I could do it. Come on. Bottom layer. Oh, it's way too thick. Hold on. Control Z. Control Z takes a second, and I'm too used to using it. Does have to go to 0.2. And then go to the bottom layer. This one can just go straight out to that. There we go. Yeah, I think that's as small as I can do it, I guess. The thing I could think of, the top layer again, is if I bump them like down here, I bump them over and then get them to go way down to the minimum distance over here. Now, I'm going to leave this the way it is. This is a little bit bad. It's a little clunky, but I'm getting them out of the way so that I can get all the V negative that I can stomach into this area. You want to do something questionable in F360 save because you never know. That's any CAD program, yeah. You start to kind of push the limits and the CAD program goes, no. And it blows up in your face. Okay, so this one goes to there. Have V plus sitting over there, ground sitting over there. We can move that a little bit. Now we got to move this one into position. It's going to require us to come down here. Actually, we'll take both of them at once. We can do route multiple. And I select 1, 2, left click, right click. nice radius there. And it's running into this one. Oh, this one needs to be a little closer. That is too close. Can I? No, I'm going to keep that. These are the same. No, they're not the same height. One of them is off grid. Oh, dear God, this one's off grid. What happens when you allow it to bump your traces. There, that's now on grid, except for all this stuff. Get out of here. What is all this mess doing in here? Get out, 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 out. No, Control Z. Okay, nice and clean. So let's grab this one and let's do one of these bendy guys. 0.2 still, grab it from here, goes straight in. There we go. Okay, and grab from here, go straight in. There we go. All right. Now our via is nice and organized. So now I can go back to the top view. And actually, I can unview the bottom for now. Oh, whoops. Right, it doesn't show me the layer on this thing. Reset top. Oh, come on. Reset bottom. Reset top. There we go. Okay, so now I've got view of just what I want to view. Hey, I told you to go away. What the hell? God damn. This program. Route multiple. 1, 2. Left click, right click. Dun, 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 dun. A nice tight bend around the vias without pushing them out of the way. Now there's the behavior down here I guess I can alter. There we go. Walk around violators, but that tells me that this is too close. Oh, and then this one should probably be on grid, huh? Oh my God, it's so far off grid. There, now they're on the same grid. Let's just check our bottom layer to make sure it's okay. It's not, we're too close. So these have to be kind of offset from one another. Means these need to go up just a little bit. There we go. That should avoid them now. So I can unview my bottom layer, which means doing the layer manager. It's going to be a complicated thing to get through the final checks. Okay, multiple, route multiple. These two. Left, right click, and then try to get it around this. Okay, I get it, I get it. I wish this was a little less clunky doing this. All right, and now we need to do 45-degree angles because this needs to go into that. That is far out of the way. That's not as far out of the way as we can get it. By no means. Surely we can do this a little bit more organized. If I really want to, I guess I could go for another loop around. It's just, it seems like the rules on these vias are a little bit limiting. Like that's the only place that's going to be. All right, so multiple. Not one of those. We're doing one of these. Actually, I should be coming from up here. Multiple can get a little moody sometimes. All right, don't do that. I'll just do it manually. Jeez. Okay, I get it. it's worried about like 60 different rules that it has to follow. Not my best work, but it's what we got. And this one is V minus, so this one's supplying this entire plane. So I can just come into this one logically. Let's get rid of this. No, 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 what are you doing? Delete, delete. Get rid of that whole thing, there we go. I'm actually gonna duplicate this. So let's look at the bottom layer and figure out what we got going on down here. And I'm going to copy this floppy and we'll put another via right there. And that gives us plenty of interface to the heatsink. These don't get that hot, but they do have a big heatsink pad, and I do want to put a couple vias in it. The green docu layer is giving my brain DRC errors. It's just the color that they use for the pads and for a documentation layer for the connector. So you got to get over your own brain. That's not on me, that's on you. 0.3. And I don't want to look at the bottom layer. Layers, display layers. See, it's like it doesn't show, even though it's enabled. It really should add the enabled layer to the preset stack. But I guess the stack's there for you to edit, so you have to kind of come back to it. Why'd you do that? Trace 0.3, this one. And we can do one of these. And this is just window dressing here. Because there will be a thing on top of it. Smooth that up. Smooth, that's smooth. Yeah, that'll do. Okay, so now we have a much larger area for all this stuff. Let's see, that one's V negative leaving. So I mean, I could really just throw that over to there, but and then let's get the bottom layer stuff done. So display layers, let's go preset bottom. And that ground's fine. It's the V negative that we now have to run, which is going to have, I mean, I could flip this over, but it's going to get in the way of my text. And we're pretty even on the V negative pin. So let's just take that one from where it is. I'll just come over here and we'll do one of these guys. And then this can go directly in, and I'll just do like a bendy boo. Ground and ground will be connected to the ground plane. V plus, we're going to have to do a squiggle there. Actually, I could, for this one, I could actually squish it up. Oh, wait, there's traces in the way. Whatever I just did, I need to undo. Because moving that might have moved traces on the upper layers. So I guess to avoid doing that as a whole. Damn it. Stupid keep out areas. So if I highlight it like that, it'll show me internal stuff. Get rid of that. And so, is this supposed to be a V plus? It's a V plus, and yet it moves it when you move it. Just like that. I don't want to break ground continuity, so we should stick on this area. So I guess I'll do just a 0.3 bendy trace, not on that layer. Come into there. Then I guess, well, this is going to break ground. So this area is not really going to get that much ground unless I come like up and around. But then ground needs to come in here as a signal. So I need that ground. So that means I'm going to need to have a via up here, and that's going to kind of cramp my style in this area. So let's get this one a little closer. Oh, but it's got this stupid big keep out area on top of the capacitor. what if I were to tell you that you move down? This moves in. Oh my God, stop being such a freaking... I hate this thing so much sometimes. I can't move because I have a trace in me. Oh, now you can move in like that. I see. That's too close on the bottom. I'd like to move that up a little bit. But, yeah, there's a trace inside of the pad, so it's not going to move properly. That's as close as we can get there. Let's copy this one. See if we can get it up here without moving anything. Good. Okay, so that means that this pad right there is going to get its ground reference. That's the important part. So 0.3 is a little bit bigger than the pad, but enough for me. That, and like that. Let me go to the top layer. This one. And like that. Now, grounds should all be connected. And our V negative is going to have a ton of heatsink space. So let's bring in all those other layers now. So let's do our view, our layer view. Display layers, and we'll just do preset standard. And then I'm adding to that, well, damn it. Used layers. That gives us way too much stuff. So we're going to get rid of a bunch of layer looks here. So silk screen stop top and bottom we want. Names we don't want, but we're going to keep top and bottom names. Values we do not need at all. Solder mask top and bottom are what we want. Yes. We don't really need the solder mask bottom. Stencil top and bottom, no. Finish, no. Glue, no. Glue bottom, no. Component exclude top, nah. Component exclude bottom, no. Restrict, no. Drills, no. Document and document. Let's get rid of the document layer. So now we're back to the view that I had before, which is a little confusing, but it has a lot of display stuff at once here, but it kind of helps me do the final evaluation of the board. So let's bring back all of those ground planes. So show the fill. Fill. And I have these ranked, by the way. The overall fill is rank 2. The V negative fill is rank 1. That way they don't run into each other. Each of your pores has a ranking, and that determines where it's run. And then the ranking is usurped by the overall like trace avoidance. So do we have all of our V negative layers displayed? I think I left the other ones on. I did indeed. You know, this one could probably be pushed up 1 too, but I really don't want to do the work. We've got 2 of them in here, and they're not totally in violation of that circle. They are a little bit. The one that we just did, where is that? That's here. Those are totally out of the circle. We did a good job on this one. It is a little cramped, but we got all of our signals in and out. So while I could have lifted these up a little bit, I'm not going to worry about that. The shadow layer mode. I haven't messed with the shadow layer mode. I don't know what you mean. The color gradings here I'm used to. The sort of shaded blue and the red, I just kind of can see. Like that works just fine for me. If there is something called shadow layer mode in this CAD program, I've never used it. The only other violation of that is this one, isn't it? So the one all the way down here. Nope, that one's out of. Those are totally out of the area, except for maybe just this little tiny overlap of the solder mask keep out. But they are out of the area that's designated on the Donkey Kong datasheet. This one, totally out of the area completely. And in fact, they might even be able to move down a little bit without violating it. But I'm going to leave them where they were. Control Z. I'm going to go ahead and leave that up there. These barely create heat. They barely create any heat, so they should be okay. So the only other ones are these two. All of the way up here. These two very much get into the area where the headphone cable potentially plugs in. And since they're V negative, they could have some pretty bad effects. The question is, do I have room to move it up? No. The answer is no. The answer is no, and then it's also no again. And then again. It's also still no. Here, the answer is yes. Answer is still yes. That one's still kind of yes. That one will move up all right. No. The V negative going into this area makes it impossible unless I could get V negative into this area another way. There's no other way. This would maybe move up to here. Which really doesn't get me out of the blue here. It's locked, I can't move it. I'm gonna go ahead and hit Control Save, Control S, before I move on. It's like we still are well within Control Z territory, so just to humor myself, unlock, escape out of the tool. Oh. What just happened? Whoa. Oh, we might actually be able to do it. Lock these down to, yeah, those are bad locations. I want them on the grid. Pictures of Spider-Man. Okay, so maybe I need these on the alt spacing grid. So those on the alt spacing grid, they are now connected to V negative. Grounds are still there. That ground still gets continuity if I can keep this line from getting in its way, which I can't. So that is a 0.3 V plus, and it goes straight in. And that's going to cut it there, but it gets ground from here, and then this loops around and it also gets ground from here. This one is V negative, and it is also surrounded by ground. So I need to make sure that this gets out of there in a nice clean fashion without cutting this one off. So I'll go actually from this corner here. Come into this, let's go like this. Ooh, that's kind of ugly. Let's hold on a sec. Kind of ugly, kind of ugly. Back here. See, these parts are not made in metric, so they're a little bit off of my grid, which makes them a little bit clunky to use. That one still gets ground, okay. And then we can just cross over to this. Just for the sake of the program, I'm just going to connect these. There we go. So now everybody is happy with where they are. I could sneak this up a little bit further, but I'm just going to leave it where it is because it's relatively centered to that area. No, this is still a 2-layer board. I've been able to keep this within 2 layers. And with some minimal finagling of the traces, we are able to get all of my goals met, which is to keep thick traces on power, relatively thin traces with not the minimal trace for all of my signals. I've got a little bit bigger than the minimal trace for all my signals. Things are laid out relatively cleanly. There are some close calls. Things are a little bit closer than I'd like them to be. That's unavoidable, especially on this many layers. But for the most part, things have been relatively clean. Can I move this out just one? Please, please, please. Oh! Okay, good. Is that conflicting up there? I don't think that's too close. No, I don't see any lines on it. Close to a grid, are you? Whoa, you're super far from a grid. All right, hopefully this doesn't push things out of the way. That's pretty good. Either one's fine. We'll leave it right there. Whew. Okay, that's good because now I don't have to worry about plugging in a headphone jack and having it wear away at my V negative. So my V negative suddenly hits the tip of a jack and blows up something. I don't hit negative 12 volts into a plus minus 10 volt thing. Now there's no chance that that's going to happen. That's a big save on my part. Control S the crap out of that. These are the little things. By the way, these are little things, right? Little things like, oh, can you move that like 0.2 of a millimeter up? And you're like 0.2 of a millimeter up. Let's take a look at the list of things that would violate. Yeah, like it's like 50 things have to move just a little bit to accommodate that minor change. That's what happens when you have a board like this where it's only 2 layers and you've got a bunch of, because this is what layout has been for me for the entirety of the weekend, is that I would sit, take the dog for a walk, get a cup of coffee, sit down, open up Fusion 360, get ready to work, get up, go into the bathroom, take a poop, get back to work, sit down at the computer, go upstairs, help somebody bring groceries in, look at the lamp that went bad, come back, sit down, look at Fusion 360, go, what the hell was I doing? I don't remember. Oh, let me move this thing just 1 tick of a grid over to the left. But then I got to get rid of this, I got to get rid of this, I got to get rid of this, and if I'm going to pull power in, I have to move this one to this side, this one to this side, these over here. So unroute, move, route, check everything over. That's what I've been doing until all of the air wires were gone. And then I put a ground plane in, and once you put the ground plane in, you need to worry about continuity of your ground plane. With a design that's this dense, it may look like a lot of this area is connected to one singular ground plane, but then you have a spot like this, where all of a sudden everything boils down and you have almost nothing passing through. This ground plane on the bottom layer stops all but right here. So that is condensed down to right here. All the current for all the components north of this trace are traveling through that. Although luckily we have a little bit of continuity of the bottom layer of copper there. So you have to worry about stuff like that. Everything can be routed to one singular trace. Why is my board getting hot right here? I miss the time when packages were either imperial or metric. Nowadays, everybody goes insane with cursed package layabouts and random non-symmetrical pitches. I don't know about that. The technology level that I'm working with is right around that time when suddenly everybody went, by the way, metric is superior, and everybody went, yeah, you're right. Oopsie. And we were mixed between SO parts and like quad flat no leads. It was somewhere in between the two. Grids are considered to be a thing of the past at this point, but they really do help sort of organize your thought with a design like this. They help me kind of keep grounded. I know in 3-dimensional design, 3D design, people are like, grids are obsolete, don't worry about grids. But I mean, they're still very useful for me because I know if I can bump this over by 4, this one goes over 2, this one goes over, it helps me keep everything kind of in line. Hey, what's up, Mr. Copper? So, you know, that's color me impressed. You're the only person that knows enough to be impressed with the design. And I appreciate you very much. This is not easy, this stuff that I've been doing here. Oh, that bumped up by 2, didn't it? Did that travel with it? And then it... No, I had that much space originally. I'm going to get this in the mail and realize there's all these areas where I could have either spread out more or condensed it more. Oh boy, we were supposed to be picking memes and trying to fit my text somewhere on this. The only text that I've fit so far is on the bottom layer, and I'll show you in the 3D design. Let's run over to the 3D design because it'll be easier to see what we get in the end. I'm going to stand up for a minute or two, though. The stool is starting to dig into the soles of my feet, and the design is starting to dig into the soul of my body. I'm losing my soul. AI study buddy. It's actually, I'll tell you something. A buddy of mine went back to nursing school, and he says AI has been extremely effective for his studies. What he does is he uses it to make practice material. I really don't like this trace right here. I wonder if I can do anything about it. See, it goes into a diagonal, and I tried to smooth it out. I guess I can't really do much about it, unless I change the diagonal to be more narrow, and I didn't want it to be more narrow because the only ground plane that's feeding this area is through this little pinch point that I've given just a tiny bit of extra mass, but I can't go any further into the circle because then it'll potentially have the ability to plug your output into whatever this is. So I think I'm limited there. I have to have this ugly ass looking intersection. Ugly, ugly, ugly. You disgust me. Can't trust it to not hallucinate. I don't know how my buddy's getting around that with nursing school. I think he's paying for one of the services, so maybe it's a little bit more accurate. But in the end, like, would I trust that with my engineering? No. I could probably move this one out a little bit and have it hug this trace, which would give me just a little bit more ground, but I don't think there's any advantage to doing that. We've given this as much heat sink as it can. This is the chip that gets very hot that we had to attach stuff to in order to cool it off. So I've got it fanning out. I don't have a heat relief on this pad. I don't know if they're gonna have a problem with that. But then I have it going to this much board area, which is not a lot. Admittedly, that's not a lot. I hope that's good for dissipating the heat. With Pro LLMs, they just get a dude on the other side to look things up on Google. A mechanical Turk. I don't know. Is that like problematic? Should I not call something that? That's when you the chess playing magical Victorian age chess playing cabinet is actually just the person in the cabinet. I feel like I should smooth this up a little bit, but I don't know if there's too many solutions to this area. Other than if I could bump that up, but I don't think I can. Move it down. I could move it up. Oh, that ground plane is important for getting ground over to here, though. So this connects to here, which gets into our little violation area. So I can't. That's one of the vital extra little pieces of ground that are getting into this area. This thing is a current hog, this chip. And so I need to make sure that it gets plenty of ground, it gets plenty of power, and that it actually is able to dissipate its own heat. So like power's coming in through this one and these two on the ends, which they thought would be totally awesome to help us lay out the whole thing, but they didn't expect you to put it on something that was just barely larger than the chip. All that heat's going to be under this connector. All things considered, though, I think I am giving it enough copper to cool off. I hope. There's not much else I can do for it. I'm sorry. And I guess if this thing is fucking on fire, that means that other chips won't, that means that when it goes into a closed rack setup and everything gets hot, it won't change the dynamics of the mixer. How much current does it pull? Ah, man, I don't fucking know. I could have measured it when we were using it. All I know is that under our normal circumstances with no load, this thing was getting hot enough to desolder itself until I added, and that might have been just a mistake in the design, but I added a little tiny piece of, there. We haven't used a microscope yet today. It is a rare day. I added a little standoff to the bottom of the chip, and that was enough to cool it off. Stick a piece of aluminum to it. Oh no, I can't. Oh no, I can't. Where would I do that? Oh, you mean on top of this? Really, the cooling is supposed to be done through that, through the center pad. But yeah, I mean, maybe I can. I've seen a synthesizer modular synthesizer components that have one of these stuck on it. No, I was thinking, because you want to cool that pad, and I had completely forgotten that you could just stick something like this on the epoxy on the other side. So yeah, I could, and I have seen it before. I could just stick a heatsink right there. Or I can rely on somebody plugging their headphone wire in and going, why is my headphone cable so warm? Really, one of the things that I wish I was able to do, oh, this is the wrong circuit, sorry. I wish I was able to scooch this one off to the side like I did the other ones. But it's pretty locked in. There's no room, just because left and right output have to have a capacitor on them. That limits my ability to scooch this thing out of the way. If I could scooch it up a little bit, maybe it would have better contact. Although 3 vias is a pretty good amount. That's a pretty good amount. The thing that could happen with this, and again, $5 PCBs mean I'm just going to yeet into it, right? I'm not going to worry about this. But one of the things that could happen with this, since it is going into a very miniaturized modular synthesizer setup, is that the internal temperatures of that synthesizer could be enough that it would have an influence on some of the components. And I guess I'm going to learn that when it happens. There's no other way for me to get around that. I'm just going to build it, put it together, get it working, make sure it works okay, and then give it to Julian and just see what he does. I do wish I could have a quad flat no lead with those other components, though. These guys. The silicon in the chip itself could probably fit into a QFN package, but all of these are SOIC, and we looked for alternatives. They just don't exist. Unless I just don't know about something. It would be great if there was a part that DigiKey had that was an alternative to this, that was a quad voltage controlled amplifier. The reason I need the quad voltage controlled amplifier is because we have 2 independent channels coming in, and I want 1 knob on it. I don't want a dual pot, because dual pots can be miscalibrated to each other. They get scratchy. If I run my audio channel through a dual pot, it can just, you know, as you're adjusting. Whereas putting it to its own op amp and then adjusting it with that makes it quieter. It makes it much quieter. High frequency harmonic distortions may or may not happen with this design. It's possible that in the future I'm going to be having to work in extra capacitors to stuff, which I don't have room for that. I don't have room for that. Good, we're keeping everything away from those centers. Good, good, good. Everybody's got plenty of ground after my little rework incident. Looks like it. That's V negative, so no, that doesn't get a via. The vias, they staple your 2 layers of PCB to one another. They give you continuity between the 2 layers, and they sort of close it off, and they make it a little bit more like a enclosure. They'll sort of give a local ground to your stuff. They'll distribute ground, and they will shield ground. Usually vias are fairly bad conductors, especially if they are few. What helps the most is either having a big top plane connected to it, usually not doable, or a big plane underneath and very close to the top, like in a 4-layer board, where the second layer, I know, is 0.1, 0.2 millimeters away. It's much closer, yeah. And heat will get into that. That's why the Raspberry Pi the whole Raspberry Pi gets warm, not just around the chip. The whole thing gets warm. It's actually one of the better heatsink designs out there. Very likely not that. In a 1.6 millimeter board, this is very likely not that useful. So if the thing gets hot, the heatsink on top is likely the best idea. Well, I mean, these things dump their heat specifically into this center pad. So having a big plane on the other layer is really what they recommend. That's really what you're supposed to be doing. So I've got 2 pins in that, and then I've got a big plane on the other side. These don't get that hot, but the other one does. I don't know. It's what they suggest. But I guess on a 4-layer board, I would have a much easier time getting that heat out. Because I would have to avoid this here, but then I could dump it to the layer beneath this. Below that, there's well, FR4 is thinner on a 4-layer board, right? I would have a 1.6 millimeter overall, but that second layer would be where the original was. Is that how they do it? Or is it going to be a thicker board? I don't know how that works. I don't know how the layer stack specifically works. But yeah, what Legoland's saying is that like getting through this is like a monumental amount of distance for your heat to travel. Not water cooling the mixer. I could, but I'm not. Yeah, hopefully this is enough to get rid of the heat. It's all I can do. All right, I'm feeling more confident in this. I'm feeling like, oh, that's a big area. What's going on here? Could probably sneak this to the left a little bit, and then this whole area I could put something in. Let's take a look. I have the window cracked, and it is freezing in here now. All right, where is my buddy? Big unrouted area. Where is that? I don't know where that is. That's a crazy amount of unrouted space right here. Hold on a second. Duplicate. There we go. Let's see if we can sneak another one up there. I don't think it'll fit down here. I just made a giant dipole antenna. Yeah, I don't think that's going to fit. Nope. Well, whatever. It's a little bit more coverage. Now, there was that giant unrouted area where it looked like I could maybe sneak a trace out a little bit. I'm not going to move RL1. That does a straight line down the whole board, except when it jukes around this thing. That would be a decent candidate. This right here. No, there's RL2 right there. Now, what was that giant open space that I saw? That wasn't there. Yeah, there's so much density to this. With enough rad size to passively cool through convection. Yes, I'm going to put a little DC pump on the back of my 2-panel module. Copy that, put that up here. That keeps it from being an antenna. Although that one does too. So, well, okay, whatever. There's a lot of antennae that I'm identifying on this board. Not a lot that I can do about it. Where was that spot? Okay, I'm going back to the... Where are you? You are on the bottom layer. You're on the bottom layer and you're by the audio chip. Okay, by the headphone amplifier. I put in the headphone amplifier. I don't know. I keep mentioning it because I don't think I'm justified in doing that. I probably should have just girded my loins and actually thought about designing a headphone circuit on my own. Instead, I decided to use something that called itself a hi-fi headphone amplifier. And I think this is getting rid of a lot of the calculative load of me figuring out what the hell I'm doing. Oh, I see. Okay, so there's no access to ground in this area. This stuff just cuts it all off. if this I sneak down, I might actually be able to. So we're going to move RMix plus to the edge of the board. I'm unrouting this, and let's look at the bottom layer only. Preset bottom. Let's bring this out to the edge of the board, and we're a 0.2, we're not a 0.3. We'll do smooth traces, why not? There. So now we have this big ground plane in this area, and that gives me a little bit of coverage for cleaning up signals. Two-phase heat pipes. Wait, I don't know about what you're talking about. I could use one of those heat pipe pads. Those are fashionable. Display layers. Standard. And then, well, see, I like to do standard, but then with the solder mask around it, because then I can see, you know, what's going to be exposed and what isn't. We'll just do this for now, though. So I can't really pop this up to the top layer. I could probably put like sneak a via in right here and get a little bit more coverage of this area, just because I've got some signal traces that are coming through here. If I pop this upwards, it's not going to do anything there because this component is blocking the entire plane. Yikes. So I'm just gonna ignore that. I have to. Area is way too tight for a lot of this stuff. But we got just a little bit of copper around it. Yeah, I think for the most part, this thing is done. This is the what I call the learning to let go portion, where I have to take a step back from this and go, you know what? This design is ready. I can park it for a day and come back and check it over when it's a little fresher in my head. But what I'd like to figure out right now is labeling stuff. So I need to label some stuff. So we did a lot of good work here. We did the keep out from the middle of the Donkey Kong. I don't need this to be here. And we sorted out a couple little areas that needed some extra ground stuff. Those are all good improvements to the board, and they are sort of final steps sort of things. Now, I don't know what for leaving out all these R's and C's that are on the periphery of the board. I'm not sure what's going to happen there. I will do the job and then I guess send it to JLC, and if they have a complaint about all these markings being off to the side of the board, I can address them later, or delete that layer, the top and bottom names. I could just avoid, and I could put all my text on the other layers. So there'll be like a document layer and stuff like that. Let me get a bottle of seltzer because my voice is starting to cut out. I'm feeling a little scratchy. Voice is a little scratchy. I think I snored last night. Oh, bottle of seltzer is literally right behind me, so I just have to grab that. And I'm going to close the window. It is cold in the Northeast. Cold, cold, cold. Cold day in hell. Ooh, that's genuinely frigid air coming in. It feels like it's actually a snow day. Well, it's not really a snow day. They cleaned up all the snow yesterday. I still need to clean off my car. My car's covered. Actually, only half of it is. Yesterday, after the snow, the sun did us the favor of melting most everything. I'm not used to this view. Okay, so what I want to do is I want to look at the, well, let's go to the layer stack. And we're going to go preset top. And we need to just look at the markings on this. So these are all, the text is in the right direction, which means that we're looking straight through our board right now. Document is not something that we can view. Restrict is not something that we can view. Component exclude is not something we can view. Names, I'm going to unview. Silk screen top is really where we're going to work. I guess there are other layers where I would be putting top PCB stuff, but I guess we'll continue to work with the silk screen. Now, there's actually nothing for us to do up here other than secret documentation. So actually, the the top component names I could maybe work into this. I would love to see the silkscreen top, guys. This is not a very good. What if I add? Oh, there we go. I could just hit plus on that. The silkscreen top, I want to have the solder mask top. So now everything inside of these little hatched lines actually gets a masking over it. There will be no, you know, the green or whatever color you select, solder mask is that shiny polymer coating that coats the board. It's a heat resistant, solder resistant layer that insulates. So that insulates the top layer of your PCB. It's very common. You guys all know what it is. I don't need to explain it to you. But I'm going to show you it. So yeah, it's just this stuff that colors your board black. In this case, is the solder mask layer. And so I want to view the solder mask layer because I can see, the same way that we're viewing it right now, we can see where the pads are going to be, depending on what our finish coating is going to be. I don't know if we're going to get like a gold coating or just have it be, you know, washed over with solder like it is here. Good enough to be washed over with solder. That's totally fine for us to assemble. And this is the original Funky Kong, the ones with the holes through the board. JLC's, well, I don't know what their layer is like, but I've ordered. Where's the one I got from JLC? Oh God, that Red Bull is still here. I hope that's not moldy. Turning into Asmongold. No, I don't quite have a dead rat alarm clock yet, so we're not quite there. Which one did we get from JLC? Let's see. There it is. The mold has wings. Ew. This is a JLC. JLC is a pretty good silk screen, and actually that size of text, I don't know how I got away with it. Their text recommendations is to have much larger text. But this is still very legible at this size. Here are those weird custom transistors that I put in. I think I was at minimal trace size. That's a matte black. Green one's decent. Everything else is pretty poor, and with a bit of rework, the solder mask goes away. Yeah, that's no good. Yeah, I mean, if they're this size, I could label them, although I don't think I'm going to. Let's open this design and see what size this text was. Because I'll go larger than that, and then I think we'll have enough room to put the text that we want all over this board. So let me close my my module testing module. That one's going okay. I'm still putting the schematic in there. I would like to get all three of these ready to order. The keyboard Flexi Design, and the keyboard Flexi Design just needs like markings. Same with this mixer design. The mixer design, the Flexi Design, and this the module tester I would like to get done all simultaneously. Oh, you know what? This one might have been archived. Hold on, let's see. We are in RC Car Projects, and this would be the DOS V3 PCB small. There we go. The purple one goes away with IPA. I've gotten the purple one before for the old, what do you call it? The old thermal imager project. I just never had a chance to rework those boards very much. Boy, I got away with a lot back then. For JLC. This was proportional 0.8 millimeter. Proportional 0.8. Well, that's not, where was the bother text that I wanted? Whole keyboard PCB using flex. No, no, no. That's not, the flex PCB is way more fragile than that. This was barely legible. And it's 0.6. So anything above 0.6 is going to show up decently. F. That's supposed to be an R, but there's V's in front of it, I think. It's supposed to be an R. All right, so, I mean, the text size should probably be a little bit larger than, at least for marking stuff, it should be a little bit larger than that small size. And then RG and B, the size of that text is, well, I'm looking for it. Where did you go? Hold on a second. Gotta find that leading edge. Like Q3. Q3 is 0.6. Oh, that's the wrong size. Side, rather. Q3 is 0.6. So if we go 0.6 to 0.8, I think we're in good territory. Minimum text height is 1 millimeter, 40 mil, and minimum stroke thickness. I know that's what's listed on the website, Ben Gizmo, but they did this on their cheap board service for me. They didn't complain about the text size because it's not laid out in traces, so. I understand what they say on the website, but I was able to order this through them, and it was fine. Unless it was on a different service that I'm not aware of. DLC does matte, right? Unless I ordered it from a different board house. Yeah, if I keep it close, like 0.8, it should be okay. PCBA, 2 layers, 100 by 100. They don't have matte. I may have ordered it from a different place. So yeah, I'll try to keep it close. They'll just ship it no matter what. You just send us the stuff. We warned you. All right, so this thing. And let's bring in the names layer for the top. Properties. What just beeped? Something beeped at me. Beep, 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 beep. Let's bring it down to 1 millimeter and see if we can work with that. That's not that much smaller. That's not that much smaller, and we really don't have room for that kind of thing. There are ULPs that will allow me to resize all the text. I just don't know which ones they are. C for change. C. And then size. 1 millimeter. Let's bring them all down to 0.8 actually. So C for change, size, and then I'm going to go with the dot, 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 and I'm going to give it 0.8 mm. What does that convert to vector text? It's already, or no, it's not in vector text. This is, but that's what they're going to do. They're not going to print. I don't know if, does JL only do vector text? Because all those labels that I had, I thought I sent to JLC PCB. They did a pretty decent job, unless I sent it to Seed Studio. Is Seed the one with matte black? No. Hold on. The hell did I order? See, their Fusion PCB service has all the design rules already in the program. Two layers, 1 by 1, 10 quantity, 1 design, 1.6, matte black. Oh, this is a Seed board. This is Seed Studio. So yeah, Seed was able to do exactly what I put down in CAD. The Seed Studio yellow also looks slick. Hold on, I got one right here. Yeah, I was thinking of ordering yellow from now on, because that looks nice. That's a nice looking board. This is the alternative Hajiwo design that I have still a lot to work with. Friend in Florida, they have snow. Holy shit. I mean, Dewey was posting pictures of snow in wherever, and that was pretty crazy, having snow in New Orleans. This is the Seed Studio yellow. JLC is just about the same capabilities, so I don't know. I don't know why I'm going with JLC. Probably just because they have Flexi. Which one did I get from JLC? Hold on, I'm gonna pull out a bunch of PCBs here and see which one is from JLC. I don't know if we've ordered them lately. I tried an alternative board maker. Like, these are the Seed Studio. Most of these in this bin are Seed Studio. And they're really good looking boards. You know, I can take all my vector art into it and put it on the board. Actually, what alligators do, or is that crocodiles? I forget which one it is. They stick their snout out of the water and lower their body temperature and just freeze. They're just cool with it. They just freeze with everything else. This was for the steering wheel project, but it's not JLC. Boy, this one was very rudimentary. It worked, though. This is Seed. Boy, howdy. I do not remember. This is a JLC. This is a JLC from someone else that we just had made. I think it's JLC. It's purple. And I'm guessing the purple's going to come off with a little bit of alcohol. And all of their text is vector. Is JLC vector only? They're just cool that I see what you did. I really didn't mean to do that. I really didn't. I'm so sick of that humor. God. So their capabilities. Did I have that open? I didn't. Let's see. Purple, yellow, blue. Material, dielectric, maximum dimensions, minimum. Tolerances, thickness tolerance, finished outline layer, drilling traces, solder mask. That's solder mask. Wait a minute, I'm looking for text height, 40 mil 1.0. Character's height less than 40 mil will be undefinable. Can I try? Character width to height is 1 to 6. Hollow carved and then pad to silk screen. What the heck? So are they vector text only? Well, they said the proportional. One to 6? I don't even know what that means. JLC PCB proportional font. I've been using Eagle for a very long time, and one of the things I've never understood is text settings. I'm getting ready to send a board to JLC PCB for the first time. Sounds familiar. And I'm trying to make sure my silkscreen text is going to work. I've attached this. I'm trying to translate what they're using as terms using Eagle. I believe their minimum text height corresponds with Eagle's size. I believe their character width to height ratio is Eagle's ratio, but expressed in a percentage. So their 1 to 6 would be 17. Don't know how to check, etc., etc. I'm not sure why they quoted a preferred ratio. They don't care. They have no reason to. The parameter that matters, really, and the only one they should quote, is the maximum line width. Really? You have to obey that. Their preferred ratio is about the highest you can get away with. Try setting Eagle's vector font. I don't want a vector font. Less than you need to maintain the minimum line width, 17%. I generally use 40 mil text at 13%. My component identifiers with my normal UK-based fab house that produces nice, sharp, legible text. By my reckoning, it should almost satisfy JLP's minimum width. Just ordered boards, shall see what the screen looks like them, and no follow-up ever from this user. Nope, there's a follow-up. So that's pretty big. It's a pretty big font. And it looks like they're all vectorized. Same thing with my copper layers. Man, I'm tempted to just like order them from Seed. Well, this one particularly. The other one is a Flexi PCB. Seed, I don't think Seed does that. Yeah, they don't do that. For a reasonable price. $413.60. Nope. Nope, no thanks. No, I'm going to go with $2. The $2 promotion is nice. The $2, this is a little bit less than... It's a little bit more than $2. My budget doesn't exactly, you know. I'm gonna go with JLC for the flexible one. If you make it too small with the minimum width, it'll just look like a blob. Dude, I don't know. I mean, they put it to the test. Of course, they have a lot of overlapping stuff too. But I mean, this is big. This is big. I don't know, why can't JLC do the stuff I was doing with the smaller fonts? It's a little bit blurry, but these are all proportional fonts instead of vector fonts. So I can use whatever font I want, make it look the way I want. Eagle will automatically generate the Gervers with vector font IIRC. Not according to what I said. I mean, these are fonts. These are not vector traces. See, I got like stylized fonts. So I don't think that's, and I didn't do anything more complicated than just say, hey, do this for Seed, output it. So yeah, I don't know. I mean, from my experience doing this with Seed, I had these in proportional mode. But if I turn them into vector, one's locked. Vector font. Then it'll turn it more into what it's going to output in vector mode. But at that size, I'm not really going to be fitting them in there. There's no real huge point in putting the markings in. You know, if I could get away with 0.8 in proportional mode, or even some of the sizes that I was using here, like 0.5, like these are 0.5 and they're still legible. Q2, Q1. For Seed Studios stuff. But I can't fit text that size in, so I guess I won't. I'll just put this back to where it was. For like J1, J2, and J3, I don't even need that. All I need is just a vague interpretation of where the device goes down, and that'll help me get things into alignment. So I'm going to keep that text off of the board. Let's jump to the bottom of the board then, and we can do the date marking and stuff. So I'm going to hit F to flip the board, and then we will go to the standard down or standard lower standard bottom view. So bottom. Oh, that's bottom silk screen. Whoops. Preset bottom. Bonk. There we go. I really need to get rid of these keep out areas on the capacitors. That's really kind of an annoying piece of this whole component. And it keeps me from making these like even. I can do that right now. Layer. Where's my layer? Design manager, errors. Oh, I also want the solder mask. So hit the plus sign and hit solder mask bottom. There we go. And then I'm actually going to go in and edit this component right now. So I'm going to edit the footprint. It's going to open up the library manager, and it's going to open up this component in the library manager. That's unique. That was a weird error. That's very strange. So this component here, name and value, we are in, I guess we're just editing this thing out. I'm just gonna get rid of this polygon and hit save. So the question is this going to populate to all the different like manage libraries, local changes? So we're going to upload that to library IO. Hit the button. It's going to ask me to replace it, create a new one. Fine, it's great. I don't know why they had that keep out area there. It's going to upload that. It's a little clunky. Takes a minute. Uploads it, downloads it, replaces your library, and you can replace it in the well, not in the schematic. I could replace it probably directly into the board layout. Eventually, when it's done, takes its time, and it highlights everything. Oh my God, it all changed because I just downloaded it from the cloud. Okay, user saved, click OK. And now I am going to jump back to reality. Oops, there goes gravity. I'm going to go back over here, and I am going to go to library and update design from all libraries used in this design. There we go. Library update, modify the board. Oh my God, all it did was get rid of these little keep out areas. That may facilitate grounds filling in a little bit. Actually, I don't know if it did, but it just cleans up the look of everything. I don't have to worry about those areas. Now we can look at the bottom of the board and we can see where all the solder mask stuff is. So you can see there's no chance that we're going to fit any of these markings anywhere near this stuff. If I put R39 right here, it would not look like R39 because these areas would not be filled in with text. While they do print over stuff, and if I tinted the vias, there's a chance that those would come out properly. It's probably not really going to look all that right. I'm going to leave the vias the way they are just because of the way I can use them as test points if I need to. I need that because we don't really have test points anywhere else. But yeah, if I tinted them, maybe I could put R39 down. And if they're doing like an epoxy fill on the vias, then perhaps it would look like, you know, the text R39. But still, it's the size of the resistor. The text is the size of the resistor. It's crazy. I don't know. Maybe it's so weird how the different board houses have such different capabilities. Because Seed Studio, without breaking a sweat, was able to do 0.5 millimeter text. It may be a little bit blurry. This is actually 0.6 something or other, but you know, it still fits. They're able to do much more artwork, I guess. So anywho, I've used 0.75 and it's been absolutely fine. Do you just counter everything all the time? You, I know you don't, but it's just funny that you came into stream going, you can only use 0.1, and then I go, all right, and then you go, no, you can only. I've counted. I've done it differently before. I'm just like, wait a minute. I want to view the bottom layer. What's this doing so close? I made layer 100 by accident a while ago, and it keeps highlighting it. Top layer. Oh, I guess I can move it down. That's a little better. Although, I probably put it up there for a reason, to be honest. Put it like there. Put her there. There. It still gets into this sort of heatsink pad, but I think that's okay. Vector fonts equals best fonts. Maybe on other stuff, but here vectors mean that they look rather clunky. I had 4 new boards from them this year, and 2 have small text. How small are we talking? But I don't think getting this down to, and like, if I went down to 0.5, what is this one? 1.27. Like 0.6. But it would still be in a vector font, so I don't know. Still be kind of hard to find a place for it. It would be doable though. That's really annoying. So anyway, back to the bottom view. So we flip the board. All of our text is the right way around. We need to look for open areas that we can put text. So here and here are decent. We're not going to get a lot of text in there. Same with here because it's blocked in the middle. There's probably no real good place. That's actually, I think, the best place is these blocks like this are the only really great places for us to put text. So, document. Draw. Text. Ah, why did you jump layer? Oh, because it thinks I'm still active on the top layer. I'm not interested in the top layer. I don't even want to see it. Grabby from the middle. Here we have the ratio. Proportional, vector, 1. We'll start with 1 millimeter. And then their line distance and proportionality. Hold on, what are the settings here? This person translated it into 17%. 40 mil. PSM BSS 32 mil, 13%. Everybody does everything in mil. I don't like mil. I like millimeter. What is that going to do? Yeah, see, it's huge. Oh, and we shouldn't be on bottom. We should actually be on... Oh, what name? Silkscreen. It's not going to fit anywhere on this design. In the middle. No chance. Why is our top silkscreen still visible? Hold on. Oh, because for some reason we were on that layer. Yeah, we should be on the bottom silkscreen. Draw. No, not an arc. Why is it still visible? What happened? Hold on a second. We're not supposed to be on this layer. Jeez. Display layers. Go away. Go away. Why are we on the name's bottom layer? Jeez. Solder mask, bottom. Finish top, no. Glue top, no. There was a glue. Oh, there's a little glue right there. Test. Component exclude bottom, no. Restrict bottom, no. Okay, there. Better idea of what's going on, and we're still selected on silkscreen bottom. Boy, the layer stack can get very annoying sometimes. So back to text. So even Twitch TV slash is going to get in the way of everything. There's a component sitting there, so that's not going to be visible. Nope, nope, nope. R12 should not be in here. Look for any other stuff that's left over. So this actually needs to be changed. Text, strp, strip. That's not going to look very good, is it? That S is going to have a hole in it. Maybe coax it up just a little bit. Maybe it'll get a little closer to the edge, but I'm not sure. Really all I can do there, though, because there's not room over here for me to fit text. Unless I really push it and make this just slightly smaller. Do like 0.8. But this is illegal and it'll explode. Yeah, 0.8 is as good as it gets. That is supposed to be the most dire marking on the entire board. It has to communicate to the wayward musician who currently can't even see straight where the stripe is supposed to go on the cable, and it's supposed to go down at the bottom there because that's the V negative line. And if that's violated, everything explodes. Well, the two diodes are in there, so hopefully it'll keep it safe. If they plug it offset, then all bets are off. So let's keep it within that size. If we keep it within that size, it's still, the text is still pretty big for me to label U's and C's and R's. It's better if I just move all that stuff off of the board. Like this C20, which is randomly there, needs to be over here. So we're going to look for any text that's been swapped around. I think I got all of it. Some of these capacitors are in weird spots. That one seems to be okay. Any other markings on the top of the board? Okay, R17, what are you doing there? Get your ass out of there. Any others? You become blind to these layers after working on the board for too long. You work on the board and you sort of learn to ignore the mess that's created from your design, but now is our time to clean up that mess. So although we have learned to not see it, we need to once again train our eyes on that sort of thing. Yeah. Oh, that takes up even more space. It's going to look like Buller, Buther. I need a long stretch where there's no vias, and I don't think I'm going to find that. Nope, that's not really going to work. We can do 121, 25. Has some chance of fitting in here. It's not really going to fit. Oh my god, this sucks. Any other stretches where it might? Nope. Well, 121.25. I like keeping the full date on there, though. I got to do the full date. Oh, that's going to get all messed up if I do it there. 4-5. Oh, so close. So close. There's got to be a place I can fit it at a 45. Be like 30, 35 maybe. No, no. Shit. Draw text. $55. When did it become the 21st? Holy shit. That has some chance of being legible. Not much, though. That's going to get cut off. It'll be I-2125. Not quite. Somewhat of a flatter angle might do it. I'm not, listen, the way we say to one another what date it is, we don't go, it's the 12th of December, the year of 2025. Uh, 60 degrees. Man, it doesn't really fit like that. Maybe dots would take up less space. That's a good idea. Ooh, that's perfect. Good solution. I don't know if that's going to get affected by the pads nearby, but I don't really have anywhere else that it's going to fit. That's like perfect. That might cut it a little bit, but that does work. And then we need to do V 1.0 point final 0.2. Go to like a 65. That's not going to fit anywhere. I don't know if I'm going to be able to fit that. Like, you got to put the one little joke in there, but maybe we'll put it at there we go. See, it's like on the stuff you can see, I want to have the Twitch TVO bother. The version would be nice to have outside of there, but I don't really think it's going to fit anywhere. I could also just let it be kind of cut off. That might actually work. Yeah, that would actually, I think that might actually work. Which begs the question, can I fit a Twitch TVO bother in there? If I can get it to just skirt around the vias. Well, the T's getting cut off and the R is getting cut off. It'll look like, oh, bah there. And that'll look like lich.tv. That's the only place it's really going to fit, though. That's the only big stretch that I've got. Like, that one's got a via right there cutting it off. Up here, nah. In there, the version number might actually fit over there. Where'd you go, version number joke? Oh, I brought it out. Yeah, it's over here. It is real difficult to fit this text. Nope, doesn't fit there. Doesn't really fit there either. Keep looking. Could just let this one get cut off. Yeah, that one would actually, that's actually kind of funny if it cuts it off like that. Since it doesn't matter, that's just the joke. Twitch TV Bother is not going to fit anywhere. I think my best bet is just letting the TV cut off. Twitch.tv/obother. Obother will still get on there though. That'll look okay. And the title of the device. A mixer. Working title, as in the absurd mixer. ABSD mixer. There we go. This is the ABSD mixer. Better if the title's all the way at the top, but there's nowhere really else for me to put it. That's getting cut off by everything. So the soonest spot that I've got is just here. It goes in line with the fact that it is an absurd mixer. So there's the ABSD mixer. I think that's good to go. I'll probably just delete the names layer for the top and the bottom off of this thing, and the rest of it is just silkscreen outlines. So all that's going on here is that these silkscreen outlines are designating where the components are. I will need to use the CAD program in order to figure out what the C's and the R's are. Well, we fit the date thanks to the dots. We were able to fit the date 1/20/125. All of my components are, for the most part, marked. They've got outlines on them to help me align things. And then we fit barely by the skin of our teeth Twitch TV Bother. That's the only spot that it's really going to go, that long piece of text. Then I guess the manufacturer will probably need space to be putting in their own designators. So there's a nice big spot right here underneath an IC. So we don't need to worry about them covering over our stuff. I don't know if I could leave a note to tell them to leave it there, or they could just figure that out on their own, and usually they'll find some spot that I don't want them to put it and put it on there, and that's fine. Because the text really doesn't affect anything else on the design. It just helps them keep track of their stuff. And then let's do right here. We're going to do line width of, what was the line width that they had for that? What are the JLC specs? .153. JLC, where you want it? Let me see, where is that instruction? I want to read it from the horse's mouth. JLC, where to put board number. Don't you answer me, AI. Oh, you bastard, they're right. Specify position when placing your order. So JLC 4 times. All right, so maybe we can, before we change all of our text size, I can go down to our nice open spot, and we can put down, we're still in the silkscreen bottom layer, so I'm going to go to draw text, same settings, JLC, JLC, JLC. This is, of course, in 0.8, so it's a little bit smaller than what they want me to do, but there's a nice spot for them to put their stuff. So then we just tell them that it's specified. Okay, cool. So back to what we were doing before, which is much more important. 0.2 is plenty big for the text size here, but we can go to 0.13. So let's go to 0.15. And we draw that. Too big. That's too big. I guess I want to do a curve anyway. Take it up to like there. And then the next one, I don't know where the center is going to be. Ooh, that's uneven. There we go. We can just take that. And straight line. There we go. We need to find a better place. Nah, this is the only good place. All right. Oh, this is all moving as one, huh? Like I say, I can't attach those. That's a strange way to do it. How they attach to each other like that? Oh, that looks painful. Funnier if they're different sizes, and funnier if it's cut off by something. That needs to be smaller. Be reasonable, you know? Oh, I can only make it smaller using this one. Okay. Line's too long. Hold on. I gotta get it perfect, you know? It's very important work. There we go. You know, even if most of it's cut off, I'll know it's there. I'm in Philly. That's not going to work. We need a new arc. We need new arcs all around. New arc, who this? Problem is now I can't alter the size of this one. It's free to not have the order number on the silk screen. You probably have JLC in that spot now. I mean, I can just tell them they can put the order number wherever they want. What's that? Hold on a sec. I think it's like a couple dollars. It's not a significant amount of money. Where's the... Hold on a sec. Three. Oh, that's cool. 2D barcode. Remove mark. Ah, it is free. Okay. Yeah, I guess you can just remove it. I thought the last time I clicked that, it added a little bit of money to the order, but calculated price is $2. Wait, what service are we on? FR4. Maybe on the Flexi it costs 2-layer, 100 by 100. PCB quantities 5. 1 design. What if I go to yellow? Dun dun dun. PCBs for the above option will start production on February 5th. Ah! Hold on, let's just see. So still $2. It's just it's going to be February 5th if I get yellow. And then no order number. Yeah, they don't. I guess you could just tell it not to do an order number and it's still free. Why would they even include that option? What the hell? I guess if I wanted to keep track of the order number, but it's not going to be ordering that many, so I'm just going to specify no order number then. They're interrupting my drawing time and it's making me grumpy. So we can just get rid of the JLC. Go order number free. I'm not the first person to do what I'm doing, nor will I be the last. Funnier if it gets cut off by everything. Really? There we go. Perfect. It's perfect in every way. What, yours aren't? I have to do it in a particularly busy spot just so that it's mostly covered over. So let's see what it'll look like in 3D now that we have all of our perfect markings on it. I should move over a little bit. I want the L to be in that area, though. Okay, take a look. Render. So they're not gonna, the silk screen is apparently the sticking point on JLC PCB, and probably the reason that I didn't use it very much is that it's harder to do all the vector stuff when in Seed Studio I can get down to 0.6 height text as in a proportional font, and it's still crystal clear. Whereas with JLC, I'm not sure what's going to happen when I get to the smaller sizes. Now, Seed Studio can tend to have slightly blurry silk screen markings, and that kind of messes with us when it comes to focusing the camera on things. But that's at those tiny little sizes. So we render the PCB. We get to see where all our text lies. And again, it does not look like a T. I really want to find a solution for that, to be honest. Everything else seems to come through, but the board production is also going to vary on how it does that as well. But, I mean, from a design standpoint, I don't really know if I'm going to be able to move that via. Let's just double check with the PCB to see if we can do anything about it. It seems like there's a lot of room here, but if we view the top layer, man, my insulin pump is going crazy right now. It is really, I don't know what's going on. It feels the need to give me a lot of insulin. It stopped making noises. Okay, so electrically, the difference between this and this, not going to be all that much. I think I'm going to go ahead and bump that up. This is, by the way, a minimum via. This is the size of via that I was using normally. It's just slightly different. So let's render that one. It'll take a minute. Waiting. It would be nice if this was more like a game engine and it updated this stuff in real time. You know, like the PCB and the schematic are actually updating in real time as you work on it, which is totally within the capabilities of any CAD program worth their salt. It would be interesting if the gurus over at, what happened there? Over at Fusion worked out a way to have it all happen at once. You know, you move the via and then it moves in the 3D model. So I can jump over to the 3D model and see everything that's going on. What happened? Huh? Wait, what you did? What the heck? Why did half of my via not move? Let's look at the drill layer, I guess. Solder mask top. That's in the right place. Drill. Where's my drill layer? Drills. Drill's still in the right spot. Did it not let me move it because of the other pad that's right here? I don't think so. Let's unview the drill layer. Drill. There it is. Top layer, go to the top layer. I don't see any reason why it wouldn't have bumped that over. Maybe just an error in the program. Maybe I had it selected or something. KiCad can do that with what, real-time updates? Does it wreck your computer? Because it seems like something that like not even a complicated game could handle. I don't know if CAD is dealing with a whole lot more baggage than a video game. Possibly not. Possibly so. All right, let's try to render that again and see if it actually does it successfully. This is a little weird that it offset that one. Why would it have done that? I mean, clearly the PCB doesn't reflect any of that stuff. Maybe if I hit save. More of it, then you move it, and then it updates the model. Fix me via. It's also weird that these still have sort of a pseudo solder mask layer. It's visible inside of the layer manager, or sorry, inside the CAD program. Just normally, you can see all the different layers and their properties. Really, you didn't move it at all? Why? What is this new problem that I'm having? You right here, you. Ah, Jesus. Flying helicopter. Doesn't render quite as HD as Fusion. Why is my view not automatically changing? I have a piece selected right here. It should be centered on that, not the middle of the board. So be it. I'm not the first or the last person to put that on a PCB. Why are we focused in on whatever is in the center of view right now? Huh? Fusion, answer me this. Need solutions. Yeah, that's where a view is. All right, I need to know what's going on here. Why did this mess up? Let me try changing this slightly. Move it like here. Properties. Ground. Solder mask off. All good. Click OK. Go back to this. Render it again. What? Oh. We need to la 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 la. I need to go to the recording drive. Oh boy. Computer not happy with bother. I'm running out of storage space. Hold on a sec. We need to, the recording is stopped. Probably because the hard drive is full. I need to open up 2 folders. So desktop. Recording. Today's the 21st. Let's take the 7th and cut. Let's put that into, I'll just manually navigate here. Put that into stream storage. Paste that. That'll free up for today. No, I don't record directly to the NAS. No, it takes one step before it gets stored. And the NAS is not, NAS is project storage. It's not stream storage. Stream storage is a vast amount of data, so they go on non-backed up hard drives. I'm not a data hoarder. I don't have thousands of dollars in order to make this stuff. Like, fine, I could easily make another file server. I don't have $400 a drive to populate it with drives and use that as my storage. I would love to, and maybe one day I'll make that much money, but for today, no, I don't. And then recording directly to the NAS uses up a lot of networks, so there's no way I'm going to do that. I record directly onto the SSD of the computer, and that way the file is as up to date as it can get with writes. And that way, if the stream goes down, I have more of my stream in there. And I'm not an IT guy. I'm sure there's a better way to do all that stuff. I just don't know it. Try again. Okay, part two. Part two. I ran out of hard drive space and I had to start over. So I've moved one file over and now I need to move more files over. So 21 part one, there's a 21 part two. At least in terms of what I recorded. What's up on YouTube and Twitch is going to be the whole thing. So you guys probably won't see a difference there, but I'm noting this down in case I ever come back and edit this stuff. How much is, what space do I have in here? Oh, I still got lots of space. All right. Although each of these is 20 gigs, 10 gigs. This is just a arrive to drive. This is a drive to drive transfer that I'm just doing to make sure we have enough space. I guess I'm not going to be live for too much longer. This is going to be like a 20-minute recording. But we're finishing up these boards, and I think we're at a point where why is that still messed up? What's going on there? Why do you hate me? I'm going to delete the VIA and build it again, and maybe it'll put it in the proper layer stack. I don't know why part of the VIA wouldn't move. I mean, it looked like it was all there. Let's just grab another one of these, copy it, and we can chuck it in right there. This looks like it's one of the larger ones. Try to find a smaller one. Copy that one. Bring it over here. And just stuff it in. It still looks like a larger one, doesn't it? Well, let's see what happens when we bring it over to the three-dimensional board. So I'm going to save. That's the other one that I'm going to do. I'm going to Control S. Maybe it's saved mid-move, right when my hard drive filled up. It's like, do I have the hard drive space to save? I don't even know. I'm not sure. I'm gonna do my best. If this whole file gets corrupted right now, I'm going to have a conniption fit and quit. It's the last thing that I need for my mental state today. The very last thing is, yeah, YouTube's still working, right? You guys are there. All right, let's try it again. Go ahead and render me a PC. PCB. It's a board file. Render me a board. The board. You know, yeah. You get it. You get what I'm saying. You're picking up what I'm putting down. Could probably use a VIA up there by the H. For vanity's sake, I don't put it in. I don't, you know, like the stitching it up with VIAs, I don't have backed up by any sort of a scientific premise at all. It's literally just something that I do because that's what you do. Supposedly it helps with all the grounding and stuff, but I don't know if we'd get away on the circuit with just having big swaths of ground plane that are unstitched. You know, that might be totally fine. It might do just fine. There we go. That fixed it. I had to delete the VIA. That was a weird problem to have, and I don't know where it came about from. But for the most part, this board looks like it is done. It looks like I've got all of... Why is the view setting so messed up? This happens every now and then with Fusion. How do you redo that? Free orbit. Yay, free orbit. Constrained orbit. Yay, constrained orbit. Maybe that's better, I'm not sure. We got markings on it. See, it's not an ADSR, it's not an AFDS, it's an ABSD for absurd. Version 1.0.final.2. We have the utterly vital marking all the way up there. And then we have our date, 1/12/25. It's not smushed in. I could maybe put it on an arc, and then maybe that would come through a little better. I have my stripe marking, which is absolutely fucking vital so that my friends don't blow up the design. And I even labeled the opposite sign with a giant plus. If they get it wrong, that's on them. I am no longer capable of blame in the event that this thing is plugged in wrong. But the components were blocking my view. No, they definitely were not. There it is with components. I see STRP right there and a giant fucking fuck off positive sign on the opposite side. There's some giant capacitors over there. This is the best I could do for capacitors. Those are going to be pricey. These are going to be expensive. They'll probably have to be like tantalum or something like that. We've got our giant ass chip there. We can read the T of Twitch because we moved that via just a little bit out of the way. Although, it's going to be under a clamp. There's no getting around that. Shit. There is no area where I could fit that better. Twitch TV / oh, what is that? Well, you're going to know who I am if you order this board, so whatever. Whatever, I can't win. I can't win. There's no space for me to put Twitch TV oh bother in the size of font that they have. It's limited to. And I don't think there's anywhere that I can put it around here that it would show up. So, whatever. Did the best we could. I mean, maybe it could go up here. Oh, but it's still going to get clamped. Like, this gets clamped. See, anywhere that there's a straightaway that's long enough for me to utilize has been broken up. You know, maybe I could move these up a little bit, and then I'd have a space just right here. But I'm not going to move components for text. The components are spaced out such as I am going to be very annoyed building this because everything is so small. Cut the clamps, you'll be fine. The clamps are actually kind of vital. They're the mechanical thing that holds these knobs in and keeps the 800-pound gorilla that's operating this thing from completely destroying their device week one. Beyond that, they'll probably explode because they're just plastic riveted in. But this is supposed to keep my friends who, I don't know, sit on the buttons from breaking them. Julian had a knob stick on one of my potentiometers a little while back, and he pulled the entire knob of the potentiometer out. The whole thing was gone. The whole potentiometer, like shaft, was gone. I just can't. These are going to break in ways that we can't even fathom at this point. As the engineer and not the user. Those could actually move down a little bit if they need to. If they do get in the way of these posts, I will have to move these resistors. But at least for the prototype, this is okay. At least for the prototype, we should have enough wiggle room and all this stuff. So, all right, I'm going to hit save on this. And the second piece of the recording, not part of the archive, is I guess just going to be what it is, you know? This is 7 minutes. 7 minutes. The session is 3:42. So I've got at least a somewhat close to a 4-hour stream going on. But the second part of it is going to be a little 10-minute sliver of stream on the end of everything. Everybody's busy, though. It's Tuesday. Tuesday, I guess, is when people are getting actual work done. And so are we. We've gotten a significant amount of progress done on the mixer. I think I am ready to order this board. The only other stuff that I could think to work on would be little tiny conveniences. And I don't think that's really going to benefit hugely from that. You know, I could potentially move some of the leads up a little bit because we got just a little tiny bit of extra space from my mathematically spacing all the leads out. You know, I could maybe scooch these up just a little bit. But those are kind of major things because those minorly bump everybody out of the way. Yeah, like that one doesn't allow for it necessarily. You need to inset and plate on the side where the clamp is kind of like a castellation. I'm not going to do that because I don't have the space to get the traces through if I do that. I was going to do a cut on the outside of the board, but doing a little tiny, it would be 0.5 millimeter of a cut because these technically clamp in on a 9mm board. So it would be a 0.5 millimeter inset cut that I don't really have room for. You know, there's a chance that I could possibly make a little bit of room for that, but our Euro rack size is a little bit bigger than 10 millimeters. It's like 10.3. So it's possible that we could get away with having the two clamps on the side. Having the two clamps on the side, and it doesn't necessarily make us too wide. I really don't want to like utilize that possibility, but this is also the initial prototype. This is the initial prototype. This is the first time making the circuit. I can spend the time on the final version to push things in from the edges. Like this one looks like I could get away with it, but there are others where I just can't. Well, that one's already pushed in a little bit, so it's possible that I could have room here already to do a little milling pass on it. But those are things for V2. This is V1. That one would definitely be able to accommodate, assuming there aren't traces on the other side of the board. And then, you know, multiple designs in one board I'm not going to do. I'm just going to order this and get 5 of these things. So I think that board is ready to order. Any of the mistakes that we've made, we will learn about when they come in. They'll come in the mail, and I'll take a look at them, and they'll be all like crap. Next stream is Thursday. I'm going to be back on Thursday. What are we going to work on Thursday? We'll work on something that's not the PCBs, because I'm working on the module tester in the background. Hey, 202 bits. 2 bits plus 100 plus wait, what's the, oh, that's a 2-bit. Shaving a haircut, your bitch. 2 plus 100 feet Nukem. Thank you, Feet Nukem. So I tried to do a little bit of like a series of doing. Yeah, I'm gonna. Well, right now I'm gonna 3D print it. Julian wants to do a design. I could move that to FR4 and do his design on FR4, but he wants to design the front panel. I'm gonna let him. It's his mixer. But I haven't gotten him. I haven't gotten him the vector files and stuff yet. I don't know if he knows how to work in vector files. He said he would do it in an image file. So maybe we'll have to translate his drawings over to a circuit board. I'm not sure. We'll figure it out though. We can do that in all in Fusion. We can definitely do that. I'm back on Thursday. I'm going to be working on something else. Maybe we'll work on some of these light bulb things. From there, we'll figure out where we want to go. We got a couple days, more than a couple days, like a week plus, that we have to wait for PCBs. And I want to do the module testing module PCB as well. That's a big PCB, very dense, lots of electronics go into it. I don't know if we're going to continue to do board design because, you know, hashtag AutoCAD ad. I've probably done my due diligence for this month. But if the streams come up, of course, we'll work on them again. And then when the boards come in and we build these things, we'll have stuff to work on as well. We will dust off Burn the Subs because there's some stuff that I need to do with Burn the Subs. We need to go sit over there and wire it up. We need to make the wiring harnesses for Burn the Subs. And I've got plenty of wiring stuff to do. I got plenty of wiring, wire to wire. What? And I need to print a little thing, a little cooler for it. Solid Electronics. What is that? Here's the $5 I stole from Amazon. Ripped right out of Jeff Bezos' hands. That's right. Yeah. If you guys have N Prime, why is that window open? What's going on with that one? Oh bother, live science and technology. Why is my stream open in another window? I must have been looking at who was online for that. Weird. Anyway, yeah. If you guys have a Prime sub, it doesn't remind you. It doesn't remind you that you need to re-up the sub. So Jeff Bezos just keeps your $5. It's part of your Amazon Prime. If you got it, you might as well just use it on your favorite streamer because it keeps that man from, you know, buying top of the line shaving cream for his head. I don't know how that works. All right, we're not going to get into my mental state today. I'm not in good shape. What I'm going to do is stop the stream. Stop the stream. You guys can do whatever you want. Before I do that, I need to actually. What are you guys doing? Wait, Tom Kowalski just subscribed. What's that all about? Kowalski. Oh, that's with a Prime. Hey, thank you so much. Thank you. No, those Primes are very important. I'm going to go to my admin channel and I'm going to update this to say that the next stream is on the. I forgot to do this earlier. Is on the 23rd. I'm starting to lose my voice a little bit. Next stream is on the 23rd. So let's put that in here. January 211th. Oh, whoops. I had the wrong date. I had the 211th of January. Well, now we have the 23rd. So if I do the end card, where is my window? Where did it go? I closed it. Oh, Solid Electronics was a 26 months. Thank you, Solid Electronics. And thank you, Kowalski, for the Prime sub. This is the end card. That's got my social media. You got a Beesky link. You got a Discord link, which is where I'll be hanging out on Wednesday. And, you know, hey, there's all the information. You guys can join me as you wish. I will be back on the 211th of January. 1 day, 20 hours, 18 minutes, and 29 seconds from now. I will see you then. Have a good one. Goodbye.